Alright, welcome to the live. Today we'll be doing A-level paper 2 practice. So first I'm going to do some questions from the 2022 A-level paper 2 at Excel, and then I'm going to do some questions that I left off yesterday from, I think it was the 2021 paper 2. So let's just jump right into it and see the first question. So question 1, figure 1 shows a sketch of a graph with the equation y equals 3 minus 2x, and that's all in the modulus. Let me just make my pen a bit smaller. Alright, cool. Solve this equation here. So whenever you're solving a mod equation, you need to imagine that this is in brackets and it can be plus or minus the thing in the mod. So the first equation I'm going to solve is 3 minus 2x equals 7 plus x. So then if I just rearrange this, I get minus 4 equals 3x and x equals minus 4 thirds. And then because you're modding it, you could also have a negative part of it. So it's minus the entire thing, 3 minus 2x equals 7 plus x. So that's minus 3 plus 2x equals 7 plus x. And if I rearrange it this time, I get x is equal to 10. I subtracted x here and I added 3 there. So these are my two solutions to this. Nice 4 marks to start off the paper. All right, so with mod equations, imagine there's a plus of it and then a minus of it, and then you get both. Awesome, nice one. So question 2. Sketching question. Sketch the equation y equals 4 to the power of x. This is a nice exponential question, so we should know what the shape of the graph already looks like. So if I just draw my axis, I'm trying to make them straight. So, why is the line not going straight? There we go. And then my x-axis. So the shape is going to look something like this, exponential increase. And we just need to label any points of intersection with the coordinate axis. If I saw this one, last night I'd be happy. So you should know that there is an asymptote on the x-axis, so it'll never touch here. The only time it intersects is here, and that is when x equals 0. And we should know that this is when y is 1. And you can check, y equals 4 to the power of 0 is going to be equal to 1. Because anything to the power of 0 is 1. Nice. So that is how we do part A. Part B, they want us to solve 4 to the power of x equals 100 to 2 decimal places. So this one, we're just gonna solve a equation using logs. So 4 to the x equals 100. And to make it easier, I'm going to take log to base 4 of both sides so I can make the left-hand side much easier to cancel out. So it'll look like this. 4 to the x equals log 4 of 100. And we can bring this power to the front because of our log power law. So x is in front, and log 4 of 4, that's telling me 4 to what power is 4? That's just 1. So I don't even need to write that. And that's going to be equal to log 4 of 100. And if I put that into my calculator, I get 3.32 to 2 decimal places. I need to make sure I round it correctly. All right, so I'm just going to check the chat. Is everyone all right with this so far? All right, cool. So nice 8 marks to start off. We should have plenty of time to do those questions, so we can give time to the harder ones later on. Question 3 is a sequences question, and this looks like it's a recurrence relation one. So we need to show it's periodic, so all we need to do is just sub in the values and show it. So if A1 is 3, A2 is going to be 8 minus 3, which is 5. A3 is going to be 8 minus 5, which is 3. A4 is going to be 8 minus 3, which is 5, and so on. So this is one period, and this is another period. So it's periodic like that. That's all we need to show. Part II, what is the order of the period? It is just 2. That's how many terms are in each period. Yeah, this is Edexcel. This is Edexcel 2022 A-level paper 2. All right. Part B, find the value of this summation series. So we are summing from n equals 1 to 85 all the terms, and they follow this recurrence relation. So I'm just going to write that out. N equals 185, a to the n. That's going to be equal to a1 plus a2 plus a3 and so on. That's basically how this an bit, because it's a sum, right? So a1 I know is 3, a2 is 5, a3 is 3, and a4 is 5, and that just goes on all the way up to 85. So I just need to think, how many 3's do I have, and how many 5's do I have? Well, I know the period is 2, So if I do 85 divided by 2, I get 42.5, right? So I know that there are 42 whole lots of 3 plus 5, and then I just have the 85th term. Well, I know odd terms match to 3's, so I'm just going to add 3 onto that. And if I do that in my calculator or in my head, I get 339. So that is the answer to part B. Does that make sense? Checking. Awesome. I'm going to move swiftly on to question 4. Question 4 is a really nice question. It is first principles proof. It's one of my first videos I did if you want to check that out too. So use differentiation from first principles to show the derivative is that. So I know that y is equal to 2x squared, and what I do is I just state the formula. dy by dx is equal to the limit as h tends to 0 of f of x plus h minus f of x all over h. All right? So the amount of period you divide by n. Yeah, that's how you can remember it. So you have the amount is 84, right? 85. If you divide that by n, you have 42 with 1 left over. So you know you have 42 whole lots of that entire thing in the period. So you've got 42 lots of this 3, 5. That means you have 1 remaining. So you just go, the first term in that period is plus 3, and then you add that on. That's how this works. This is 2022 paper, and this is A-level at Excel. All right, so going back down here, I've stated the formula is limit as h tends to 0, and then I just write it out. And the way you do this is wherever you see the x in your f of x, which is 2x squared, just replace it with x plus h in the first one, all right? And the annoying thing is you have to write out this limit as h tends to 0 every time. So this would be f of x plus h, sorry, why am I rewriting that? This would be 2x plus h squared minus 2x squared all over h. So you see, I just replaced that x with the x plus h. Now I just do the limits h tends to 0 again, and I'll just expand my brackets, x squared plus 2xh plus h squared minus 2x squared all over h. And if I expand out, I have, again, the limit as h tends to 0, 2x squared minus 2x squared, that just goes out. What exam board is this for? This is A-level maths, and this is EdXL. But further maths also is in EdXL too. So 2x squared minus 2x squared cancels out. Then 2 times 2xh is 4xh. 2 times h squared is plus 2h squared all over h. And I can divide through by h. So again, lim as h tends to 0, 4x plus 2h. All right, so we're just dividing by h. I don't do decision 1, sorry. I did further stats and further mechanics for further maths. 1 of each. All right, so now all we have to do is evaluate our limit here. So as h tends to 0, 2h is going to tend to 0, right? So therefore, 4x plus 2h tends to 4x. So then I can just say, therefore, if y equals 2x squared, dy by dx is equal to 4x. I just like to write the whole conclusion right at the end. It just sums it all together. So yeah, nice 3 marker, which you can prepare for. Like if you got this in the exam tomorrow, it should be easy marks, 3 marks right there. All right, so let me just check these comments. This is one of the easiest things, trust me, you'll be fine if you put the work in. Yeah, just need to put the work in, just do a bunch of questions, all right? Bang out a ton of questions and you'll be set for maths, past paper questions, all right? Because they tend to like sometimes repeating the topics. So yeah, I'm just gonna have this question on the screen for a second. My pen is on low charge, so just gotta charge that for a sec. So this is a trapezium rule question. It's easy, it is in the formula book, yeah. And it's all about subbing in the right values and not making a silly mistake in your calculator for this. But part B looks a bit interesting because we're just doing transformations on that. So yeah, this topic didn't come up in the 2024 exams. I don't think it came up in A-Level 1, your paper this year. So it could come up in paper 2. If it did, it'll be very good. All right, so let's get right into it. So the formula for reference, which is in your book, is from alpha to beta y dx is roughly equal to a half h y0 plus 2 lots of y 1 plus all the way up, and then you have 1 lot of yn. That's basically just adding a bunch of these trapeziums together, but a shortcut method, right? So part A, Use the trapezium rule with all values to find an estimate for this. So I'm just going to write my log out. 3, 9 log 3 to x with dx is going to be equal to a half. And what is my h value? That's the difference between the x values, right? Imagine you're plotting this on a graph, x and y. H is the difference on the x. That's going up by 1.5 each time. And then I have to just put in my values. So I've got one lot of 1.63 plus two lots of all the middle terms. So that's 2 plus 2.26 plus 2.46. And I have one of 2.63 at the end, plus 2.63. So if I put that into my calculator, I get nice 531 over 40. Good 3 marks there. And again, doesn't take long at all, so we can save that time for later questions. All right. If you know a question, do it quick, move on. This is Edexcel 2022 paper 2 for A levels. All right. Using your answer to part A and making your method clear, estimate these two integrals. All right. So just look at what is happening to this integral and compare it with the first one. So if I write this integral out, I've got 3, 9 log to base 3 2x to the power of 10, right? I could just use my log laws, right? So exactly, I'm saying the correct answer in the chat. So the 10 is a power of a log, right? So this can just be brought out to the front, right? So this would be 10 log to base 3 of 2x. And because I have a constant and I'm integrating, that constant can just be put in front. So that's just going to be equal to 10 lots of 531 over 4t, which is just 531 over 4. So for this one, I just use the log law, brought it to the front, and remember when you're integrating, the constants can be factorized out to the front. And if you have multiple terms, it has to be a common factor with them. All right, so part 2, I'm going to write out the integral 3, 9 log 3, 18x with respect to x. All right, let's see what I'm doing here. The question above has log 3. The only difference is this. It used to be a 2x, right? I can easily just separate this out. So I'll have 3, 9, and with log laws, I'm kind of going backwards on this one, right? This is the multiplication log law. So I'm going to do log to base 3 of 9 dx plus the integral of 3 to 9 log to base 3 of 2x. Because I know what this one is, right? So then if I just evaluate this integral, well, 3 to what power is 9? That's 2. So I'm just integrating 2, which is 2x, between my limits of 9 and 3. And I'm adding this integral, well, I know what that is from above, 531 over 40. And if I just put in my values as I'm integrating, I do 18 minus 6 plus 531 over 40. And put that into my calculator, I get 1011 over 40 as that answer. All right. So just see my advice if you were getting these types of questions is see what you've already got in part A and how can you get that from part B. Yeah. Sometimes you need to be a bit creative by multiplying or dividing, adding, splitting things up. So it's all about just looking for patterns and putting those in place. Does this make sense? Hopefully. All right. I'm going to just stay on the screen for a second before I move on to question 6. All right, glad it's making sense. All right, cool. Let's move on. Question 6. If you're doing your paper and you see a weird, obnoxious looking graph, most likely you're going to have to do some numerical methods question. And you can see down here, Newton-Raphson method is here. The marks for this is different answers due to being an estimate. So for this question, are you talking about, Owen? Question 6? So for this one, it's a bunch of, it's just, how do I say, differentiation, right? So figure 2 shows a sketch of part of the curve with question 5. All right. So let me check what the mark scheme says. Actually, I've got the mark scheme on here. That's my solutions. So mark scheme question 5. So here, answer is rounding to 25.3. So if your answer rounds to that number, if you're a little bit off, you'll still get the mark if you put it as like a decimal. So that's how you do it. And yeah, and because it's an estimate, so you won't be allowed a lot of leeway because they've given you the values to use in the trapezium rule. Because you can see up here, you're just subbing in the values and you're adding them, multiplying them to get that answer. So they won't be too lenient on estimating there. The reason you're estimating is because you're using areas to find you're using trapeziums to find the area under a curve. All right. So question 6. Figure 2 shows a sketch of part of the curve with the equation y equals f of x, where f of x is 8 sine a half x minus 3x plus 9. X is measured in radians. Really important you know this, so make sure your calculator is in the right mode. The point P shown in figure 2 is a local maximum point on the curve. Use calculus and the sketch in figure 2 to find the x-coordinate of P to 3 significant figures. Alright, so using calculus, all you have to do is, differentiation. So f of x is equal to 8 sine half x minus 3x plus 9. So the derivative of that is when I'm differentiating a trigonometric function, I multiply by the coefficient of x, so that would be equal to, great, it's disappeared. So f dash of x is going to be equal to half times 8, which is 4, and then sine x goes to cos x, so cos of a half x, and that's minus 3, the constants disappear, and we are told that it is a maximum point, which means stay straight point, right? So we've used calculus. When is this equal to 0? Let's solve for that, right? Because f dash of x needs to be equal to 0. So if I solve this, I have cos of a half x is equal to 3 over 4. I just added 3, then divided by 4. So I'm going to scroll down a bit. A half x is equal to cos minus 1 of 3 over 4. And remember to be in radians. So a half x is going to be equal to 0.722 ... And now I would think that that is my solution, but it's not, because remember, it says to look at the sketch. Here in my sketch, I've got a turning point up here, which is a maximum, but then I've also got a turning point down here, which is a minimum. P is my third turning point, so that is going to be my third solution to a half x, or x when we find it later. So I'm just going to use my cosine functions to find the next two solutions onwards. So my next one would be 5.56 and so on, and then my last one would be 7.00 and so on. So why does it have to be in radians? The question specifies that we're doing this in radians. Alright, the trig function is in radians. And then later on, we're going to have to differentiate because Newton-Raphson, and that can only be done if trig is done in radians. Alright, so notice this is the trick to this question here. It is your third solution, and you're just going along the cos graph. Alright, so then that's a half x, right? So x is going to be equal to, oh no, I hate when it does this. X is going to be equal to just 7 times 2, which is 14. And that is it to 3 significant figures there. So then it says the curve crosses the x-axis at x equals a, as shown in figure 2. So yep, it exists. Given that to 3 decimal places, f of 4 is that and f of 5 is that. Explain why a must lie in the interval 4 to 5. This is at Excel paper 2 2022, A level. So why does it lie in the interval? Well, notice there is a change of sign. So we need to say two things when we get this type of question. So part B, there is a change of sign in the interval. So the main thing is change of sign in the interval for 5. And yeah, I'm seeing it in the comment section. The function is continuous. It's very important you say both of these. You have to say that there's a change of sign and that the function is continuous. Which paper would you recommend doing? I mean, because I got high scores, so doing is a bit pointless. Do maths questions and do the harder ones from there if you want to challenge yourself. How do I get 14? Sorry, I'll just go back up here. So here I've got my half x, right? And I've solved that using cos to the minus 1 of 3 over 4. And these are my first 3 values. The reason I found 3 values is because you can see in this graph, I've got a maximum first, then I've got a minimum, and then P is my third state point, right? Which is a maximum. So I need to find when x equals to 0 the third time along. So that's a half x. So x is going to be equal to 2 lots of 7.00, which is 14. Hopefully that helps. All right. So part B, nice 1 marker. Now I need to do part C. Taking x0 is 5 as a first approximation to a, apply the Newton-Raphson method once to f of x to obtain a second approximation to a, show your method, and give your answer to 3 sig figures. Alright, so what I do straight away is at the top I put 3SF here so I don't forget. Okay, so x of 0 is equal to 5. So I'm going to write out the formula first. X of 1 is equal to x0 minus f of x0, so I'm subbing that into the function, over the derivative of the function. So x0 is 5 minus, and if I put in 5 into the function, well, my original function was this thing up here. So if I put in 5 there, I get 8 sine of 5 over 2 minus 15 plus 9. And that's over the derivative. Well, I've already differentiated. Do we need to memorize? No, you don't. It is in the formula booklet, Ella, so don't worry about that. And then I'm doing the derivative, which is given over here, so that's just 4 cos 5 over 2x minus 3. 5 over 2 minus 3. And if I put this into my calculator and round to 3 sig figures, I get 4.80 to 3 significant figures. So this is, I'm doing the Edexcel 2022 paper 2 fillet. So this was a nice question because it was just it's kind of like what the textbook makes you do, right? You have to differentiate a bit. The part A is the trickiest one, and it is worth 4 marks. So that is why it was a bit mean there. But then part B and part C are quite nice to do. So yeah, that's how you do question 6. Going to move on to question 7. Question 7 is a binomial expansion question. I've heard that this could come up in paper 2 because it hasn't already been assessed yet in paper 1. So 7a, find the first 4 terms in ascending powers of x of the binomial expansion of this thing here. Write each term in its simplest form. Iteration came up, not Newton-Raphson. Alright, cool. So Newton-Raphson could come up again, like as well, because it hasn't been directly assessed. So part A. I've got square root of 4 minus 9x. I need to write this in a form that I know how to expand. And if you look at the formula, yeah, I need to get it into that form exactly. So I need to get it into the form 1 plus x to the power of n, alright? So let's rewrite this. So square root of 4 minus 9x, well, square root means to the power of a half, right guys? So that is just 4 minus 9x all to the power of a half. Now, notice the formula I know how to use means that I need a 1 here. I've got a 4 here, so I don't want that 4. So I'm going to just factorize out that 4. So I go 4, 1 minus, and remember, you're also dividing the 9x by the 4. So 9 over 4x. And this is all to the power of a half. So what is 4 to the power of a half? Well, that's just square root of 4, which is 2. Multiply by 1 minus 9 over 4x to the power of a half. Does that make sense so far, guys? Just checking the comments. Trapezium root, yeah, it could likely come up. It didn't come up last year. I'm in here, then I think I got an answer. Should I teach my lesson? You don't need to teach yourself A-level maths in the summer. Don't worry. Like, you can still get A stars and high grades, but if there are things you do struggle with, you can go over those in the summer. But don't like use up your entire summer vacation just studying. All right, you don't need to do that. Trust me. Okay, cool. So I have this, and now I can expand this. So I'm just going to write it out on the side. So 2 multiplied by 1 minus 9 over 4x to the half. And the main mistake that people make is not multiplying by this 2. So I just put that in every step so I don't forget. Okay, so that's going to be equal to 2 square brackets. Now I just sub into my formula. Okay, so my formula tells me that the first term is just 1. Then I have plus nx. Well, n is a half and x is minus 9 over 4x. Remember the negative sign there? So that's minus, so that's plus a half times minus 9 over 4x. Then I have plus n, which is a half, and I'm just doing n minus 1, which is minus a half, over 2 factorial. So this is like over 1 factorial, 0 factorial, so this would be 2 factorial, and I'm doing minus 9 over 4x whole squared. All right, then I need 4 terms, right? So my next one would be plus a half, minus a half, and then I take away 1 again, minus 3 over 2, and this is over 3 factorial. And then the power would be minus 9 over 4x whole cubed. all right? And then so on, plus dot dot dot, all right? So now if I just evaluate these in my calculator, I have 1 minus 9 over 8x. It's important you don't mess up the signs, all right? So then you have minus 81 over 128 x squared minus 729 over 1024 x cubed minus and so on, all right? Because remember, it is an infinite thing. And then if I just multiply the whole thing through by 2, I get 2 minus 9 over 4x minus 81 over 64x squared minus 729 over 512x cubed minus and so on. And have I answered the question? Yes, I've written each term in its simplest form, and I found the first 4 terms. Do I square the minus 9 over 4? Yeah, I do. In this step here, when I'm doing it squared, and then in this step, I cube it. So remember, you have to square x and its coefficients, and the sign as well. So don't mess up your signs. That's the only main difficulty with this, and you are given the formula in your book, so you just have to sub in. So part B is a bit of a weird one. A student uses this expansion with x equals 1/9 to find an approximation for root 3. So if I just put in 1/9 as x into my calculator into that, I get that that is equal to the square root of 3. 4 minus 9 times 1/9 is just root 3. Using the answer to part A and without doing any calculations, state whether this approximation will be an overestimate or an underestimate of root 3 and give a brief reason for your answer. What are the predictions? Maths paper 3 is over. I'm doing a A-level maths paper for that comment. And what are the predictions for partial fractions mixed with differential equations? I have a gut feeling that could come up because I love having that. I think one of the questions towards the end does that. I think that's like the third last question. But yeah, and trust me, if you don't like that question, hopefully after watching my live, you're going to look forward to it because I'm going to make it as easy as I can when I'm explaining. All right. So part B, this would be it would be an overestimate when using this. Why? Because all the terms after the first one are negative. So the difference would get smaller and smaller and smaller when you're subtracting from 2, right? So you're going to get not so close to the answer, which is why it would be an overestimate. So yeah, part A, standard. Part B, they may always ask. So last year, I think the binomial question was standard binomial for part A, and then we just had to infer that the validity range was out of bounds when a student did some calculation, because I always had that, and that's how you would do that. All right, checking the comments. If Cartesian or parametric comes up, I'm cooked. All right, with parametrics, it's just about taking the x's and taking the y's separately, and then like trying to find t in terms of those. Integration by parts. There was integration by sub and by parts. That's definitely comment. All right, sorry. Can I scroll back up? Sorry about that. I will scroll up. Is this fine? All right. Just stay on that screen for a little second. The next question is going to be an integration question. All right, nice. It's just a standard integral. All right, no worries. Let's go on to question 8. So, standard integral, standalone question. Figure 3 shows a sketch of part of a curve with equation, and there's my equation there. Beautiful. The region R shown shaded in figure 3 is bounded by the curve on the x-axis. Find the exact area of R, writing the answer in this form. All right, so we need to just make a note here. What do we want to find? The area, not the integral. This area is under the x-axis, so it's going to be negative, which means that if we have a negative value, we just need to flip it to get the positive value there. All right, so when I'm integrating, they've not given me any limits. I don't think they've even mentioned that we need to integrate, right? But just looking at it, it looks like an integration question, all right? So what are my limits? They are here and here. So that is when y is equal to 0. So x minus 2, x minus 4 is equal to 0. If I have a denominator and I just multiply that out, like the 0 would just go away, all right? So you just care about the numerator when solving for 0. So that means that x is just equal to 2 and 4. And looking at this diagram, it makes sense, all right? So I am going to put this into my integral. So the area is going to be equal to the negative, but I'm just going to get rid of the negative sign for now. The integral from 2 to 4, and what's my function? X minus 2, x minus 4, all over 4 root x with respect to x. Now looking at this looks obnoxious to integrate. Does anyone in the chat want to tell me how they would go about integrating this? Expand. Yes, that's how I would do it. I would expand and I would simplify because I've just got powers of x's, right? And it makes sense. Quotient rule is for differentiation. By parts, I think it can be done by parts, but it will be quite long. So I'm going to show you how I would do it. And you've got some powers of x's. That's all you're dealing with, right? You've not got anything weird going on. If it's all algebra, just see if you can make it using x powers. So if I just expand out the top, I'm just going to do this up here. I get x squared minus 4x minus 2x, so it's minus 6x, plus 8 over 4, and what is square root of x as a power? X to the half. All right, so now if I just put this back in, I get the integral from 2 to 4, and I just rewrite this, that would be 1/4 x. 2 minus a half is 3 over 2, and then minus 3 over 2x to the half over there, because that's 1 minus a half. And then I'm doing 8 divided by 4, which is plus 2x to the minus half, because there's 0 minus a half right there. And now that is with respect to x I'm integrating. So now I just have to integrate this, nice and easy. Increase the power by 1, that's x to the 5 over 2. 1/4 divided by that, I get 1/10. And then I do increasing the power by 1, x to the 3 over 2. Divide that through, that just goes away. And then increase the power again on this one, I get x to the half, and then that's 2 divided by that is plus 4, and the limits are 4 and 2. Alright, now all I have to do is just sub in my 4 and 2, so I have 1/10 of 4 to the 5 over 2 minus 4 to the 3 over 2 plus 4 times 4 to the half minus, and now I just put in the 2. That's 1/10 times 2 to the 5 over 2 minus 2 to the 3 over 2 plus 4 2 to the half. If I just evaluate this, I get 16 over 5 for the first set of brackets minus 1/10 times 4 root 2 minus 2 root 2 plus 4 root 2. The reason I've done this longhand way is because if you try and put these into your calculators without like putting the root in, you won't get exact answers, and they want this inexact answers. So I've just done it manually myself. And now if I just expand out, I get 16 over 5 minus 12 root 2 over 5. So that is what my integral is equal to. But remember, they want the area. This was a negative area, so all I got to do is make the whole thing negative. So then I just say, therefore, the area is equal to 12 root 2 over 5 minus 16 over 5. So that's how you do this integration question. The mark scheme does say, though, that they will accept the first answer over here, 16 over 5 minus 12 root 2 over 5. So they weren't being too harsh there, but always remember to just check what the question wants you to find. If they want you to find an area, find an area, all right? If they want you to just evaluate the integral, just take the answer as is. So, does anyone have any questions about this? Or I'm good to move on. All right, cool. Let's move on to the next question. Question 9. All right, question 9, I found a bit, like this was just my opinion, I found it later on a bit evil. So at Excel, they love making questions where you have to find like an equation, like just make your own equation. So let's just read each point and take it one at a time. Figure 4 shows a sketch of a Ferris wheel. The height above ground, h meters of a passenger in the Ferris wheel, t seconds after the wheel starts turning, is modeled by the equation h equals the modulus of a sine bt plus alpha, where a, b, and alpha are constants. Figure 5 shows a sketch of the graph of h against t for one revolution of the wheel. So it's important to note that that is one whole time around. Given that the maximum height above the ground is 50 meters, and the passenger is 1 meter above the ground when the wheel starts turning, and the wheel takes 720 seconds to complete one revolution, find a complete equation for the model, find the exact value of a, b, and alpha to 3 sig figures. So I despise these type of questions, but there's always a foolproof way to get these marks, and that is just take each bullet point one at a time. I have a video where I did this for a quadratic, and I said the exact same thing. Bullet point one at a time. All right, so part A, let's take the first one. So I know maximum height, h max, is equal to 50, right? When is that maximum height going to occur? When this sine function is at its max, right? So sine bt plus alpha is at its max. So therefore, a is going to be equal to 50, right? What is the max value of sine? That's 1. So h is basically equal to a times 1, max 50. So a is going to be equal to 50. So then I just say this is my first bit done. All right, so I've worked through the first bullet point. That's what I get. All right, cool. Cross that out. Look at my second bullet point. All right, at t equals 0, h equals 1, right? Because when the wheel starts turning, well, that's at t equals 0, the height of this passenger is 1. So let's just sub that into my formula. So I'll just bring the formula there. So 1 is equal to the modulus of 50 sine alpha, because t is 0, right? So bt goes away, so it's just sine alpha. And now all I have to do is just solve for alpha, because that's my only thing missing here. So sine alpha equals 1 over 50, which means that alpha is sine minus 1 of 1 over 50, which is equal to 1.15 to 3 sig figures. Remember, that's how much they wanted it to. So then again, I'm just going to put a box around there. Is this making sense so far? On the mark scheme, it is plus or minus 50, just in case you get negative answers and you do your equation a different way. Because notice, it is in the modulus function, right? So plus or minus 50 would be accepted for the answer there, because it's in a modulus. All right, now the last one is the hardest part. So the wheel takes 720 seconds to complete one revolution. Okay, so I'm just going to make that note into like words I understand. So one cycle is equal to 720 seconds. All right, so if I look at this graph here, figure 5, I haven't used that yet, right? This is 2022 paper. So it's telling me that one whole cycle is 720. So over here is 720 seconds. All right, so what I have to do, the b is next to t, right? That's the only thing missing. I've got a, I've got alpha, I need b. The b offsets the stretch, right? Because remember, it's changing the t-axis, so it's a stretch horizontally. So b affects stretch horizontally, yeah? So if I just do my normal sine graph to see how much it has been stretched by, there's my sine graph. And I know 0, 180, 360 for reference. I'm being told that the function has 720 there, right? And notice it is a modulus function, okay? So that means that if I just did the modulus of sine, this bit would go up there, right? This shape, now I need to just see, look at the shape I've got here. It's bouncing up and up. Now if I look at the shape they have up here, I've got bounce there. And that takes 720 seconds. Well, normally it does this in this section here, right? So does shape in 180 degrees normally. So one revolution is equal to the first 180 degrees. So now, this normally 180 degrees, but now it's taking 720, well, t could be degrees, yeah? So how do I get from 180, just saving, how do I get from 180 to 720? I multiply by 4. So this is a stretch horizontally by a scale factor of 4. Does that mean b is 4? No, b is not 4. Why? Because remember, if I want to stretch horizontally of 4, I need to stretch it by 1/4 x, because x is illogical. Therefore, b is equal to 1/4. So now I just need to state my complete equation. So h is going to be equal to the modulus of 50 sine 1/4 t plus 1.15. And that is how you would do these types of questions. Take each bullet point one thing at a time. So the first two are generally accessible for most, but then the last bullet point is where you have a bit of like trig transformations. Wait, I don't get it. Which part do you not understand? I'll try and explain it again. So yeah, work your way one at a time. And then is it the last bullet point that you don't get? The 1/4 bit. All right. So yeah, that bit is all right. So let's start fresh. Okay. So the wheel takes 720 seconds to complete one revolution. So I've labeled this graph, which shows one revolution, as 720. Hopefully that's making sense so far. So I've got a sine function as my equation, right? So sine normally looks like this curve here, and I've labeled 180 and 360. If I'm doing the modulus of sine, well, this bit is going to bounce up, right? Because modulus is never negative. So I've just got two bouncing shapes, bouncing curves on top. So normally, that bouncing shape there, I'm going to see how am I going to get from this graph bouncing shape to this graph up here. Well, that is doing the one bounce in 720 t, right? This is doing one bounce in 180 t. So if I have this sine graph and it's taking 4 times as long, this is going to be stretched horizontally by a scale factor of 4. So that time is not 180 seconds, it is 720 seconds. So imagine you've got this and you're pulling it 4 times across. That is one bounce. So 180 to get to 720 is multiplying by 4, which means that you're transforming your function f of x 1/4 x, because remember x is illogical, which means that b is 1/4 because that's the coefficient of t, which is like our x in this one. All right, so then I just put it all together and then I get that as my equation. Does that explanation kind of help again? So quick summary, I see my graph, that my normal sine graph, and then I see how am I going to get from this graph to this graph based on the periods. I'm glad it makes more sense now. What topics do you think should be prioritized for tomorrow's EdXL? I heard the differential equations didn't come up, so definitely make sure you are 100% secure with those. They love assessing that topic. Parametric, difficult things could come up, so make sure you are fully confident in parametrics, because I think that comes up every year at some point. Last year's parametric question, I remember it being quite easy actually. What if I just skip my exam? Do I think modeling will come up? Modeling could come up in literally anything. And nowadays, the papers have a lot more modeling in them. I heard they're trying to make them all more real life based. So make sure you can understand context. Like this, if I got rid of the Ferris wheel bit and that weird graph bit, most people probably could get this if it was just saying, oh, this is a trig transformation question. What is the scale factor and stuff, right? But they didn't. We had to try and infer what the hell is actually going on here with this weird Ferris wheel. And sometimes I see like the more fun they make like a model, the harder the question is. Can I look over partial? Yeah, that is. I think that comes up later. Luckily, Let me just confirm. Yeah, look, this question. This I think would be perfect practice for the paper tomorrow. How is b 1/4? All right, so if I just show you up here, so I mentioned about we're stretching the normal sine graph, which is here, and I've done the modulus, so this b is jumping up, and then this is what the graph looks like now for one revolution, Yusuf. So it's telling me that that's being done in 720 seconds, because that is my third bullet point there. So it's being done in 720 seconds, but that first bounce is normally done in 180. Well, what is that transformation doing? I am stretching it horizontally by a scale factor of 4. And if I remember my graph transformations, to stretch horizontally by a scale factor of 4, I'm doing f of 1/4 x. Because x is illogical, right? If I scale by a scale factor of 1/4, then it'd be f of 4x. So remember, it's just always a reciprocal for x. So that is why b is equal to 1/4, because it's the coefficient of t, which is like x. So hopefully that makes sense, Yusuf. Yeah, the king of frauds there is because you do f of 1/4, you stretch by f of factor of 4. Perfect explanation. All right, and there is a part b to this. I'm just going to talk this one through. Explain why an equation of the form the same thing plus d, where d is a positive constant, would be a more appropriate model. So, well, if we think about this, if we look at this model, the value of h could be 0 if we sub in, right? Because sine could go down to 0, because that's the minimum value. Well, is the passenger touching the floor in this Ferris wheel? No, they're not touching the floor. So that means that if you add on this d as an offset, the passengers won't touch the ground, because originally it could be 0. So that's how it works. Is it plus or minus 50, not just 50? So because the reason I think they are putting that is because it's in a modulus function, right? So if you put negative 50 into this, because you're modding it, it's going to become positive 50 anyway. So the reason I'm putting 50 is because, well, that's the maximum height and it's a positive height, right? But if you put negative 50, you would still get the same answer because you're modding the entire function, right? But to me, I don't like dealing with negatives, and that's just messy. For part D, how do you come up with that type of answer? All right, so this one is the modeling type, right? The 1 markers. For part C, what do you mean for part C, sorry? How comes it doesn't start at 0, but then at 720 it does start 0? So yeah, that's because the second bullet point, it says the passenger is 1 meter above the ground when the wheel starts turning. So they're starting 1 meter above the ground, then it's showing they touch the ground. Sorry, this arrow is meant to be like a little like there. That's 1 complete revolution, all right? But then I've just ignored that weird little nuance to just translate it, because again, if I just had that little offset on this sign graph, it would give me the exact same. So that is how this question. How do you find B? I don't understand. I got A and A, but not B. All right. So I'm going to explain this one more time. If you still don't understand, I'm going to try and post this live by tonight on my YouTube channel. It's got the same name. So you can just fast forward to this. So one more time. Third bullet point, the wheel takes 720 seconds to complete 1 revolution. All right. That's shown by this graph. And what is that graph? Well, it's a sine graph that has been modded. So if I do my normal sine graph, which is like that, and I put in the mod function, I have this bit bouncing up too. So I'm seeing 2 bounces there, but in the figure 5 here, I'm seeing 1 bounce. Well, 1 bounce here takes about 720 seconds, but normally it would take about 180 seconds on a sine graph, right? So I'm thinking, okay, B is a horizontal stretch. I know that, right? Because it's along with my T axis. So how am I going from 180 to 720? I multiply by 4. So it's a horizontal stretch by a scale factor of 4. Well, how do I represent that as a function? Well, that's just f of a quarter x, because remember, x is an illogical thing, right? If I want to stretch horizontally by 4, I do it a quarter. So that means that b is equal to a quarter because it's the coefficient of t. Awesome, no worries. I'm gonna move on, and if you guys want to rewatch this, go check out my YouTube channel. Little promotion there, but yeah. All right, question 10. The function f is defined by f of x is equal to 8x plus 5 over 2x plus 3. Find the inverse function of 3 over 2. So first, I just need to find the inverse function of f of x, right? So I'm going to set y equal to this, 8x plus 5 over 2x plus 3. I'm going to rearrange for x, so I'm just going to multiply out. 2x plus 3 equals 8x plus 5. That's 2xy plus 3y equals 8x plus 5. And if I just bring the x's onto one side, I have 2xy minus 8x equals 5 minus 3y. Factorize out my x and divide through 5 minus 3y over 2y minus 8. So that is the rearranged thing. So then I just say, therefore, the inverse function of x, and now I just replace this with x's, because that's my function, right? 5 minus 3x over 2x minus 8. This is a standard GCSE type inverse, but then it's 2 marks on the A level. Why? Because you have to just sub in your 3 over 2. So then I just say the inverse function of 3 over 2 is equal to 5 minus 3 times 3 over 2 is 9 over 2 over 2 times 3 over 2, which is 3 minus 8, and I get negative 1/10 as my answer. So 2 marks for all that working, but it is a pretty standard question. So yeah, inverse functions, if you still struggle with those, just set your function to y, then rearrange for x to find what x is, and then that big chunky bit where you've got a bunch of y's is your inverse function, right? Because it's in terms of y. Inverting it means going from x to y, but then just rewrite in terms of x, because that's what your function is done. All right, so part B, show that f of x is a plus b times 2x plus 3. So it's not telling me what I have to do. It's just telling me to show something. Well, what exactly is being done here? Here, I have a constant, like an integer or something, plus a fraction over the same denominator. This looks like I'm dividing, right? Where I've got an integer and a remainder. So I'm just going to do some polynomial division here, all right? So if I'm doing that, I'm doing 8x plus 5 divided by 2x plus 3, right? Numerator by denominator. How many times does 2x go into 8x? 4. If I multiply this thing through by 4, I get 8x plus 12, and I subtract to find my remainder. 5 minus 12, negative 7. Well, that's it. So I have 4 was my remainder minus 7 out of what is my fraction divided by 2x plus 3. So 2 markers for a simple polynomial division question. I say simple because it's kind of short, but yeah, that you just need to infer that's what they're asking you to do in part B there. All right, next part. The function g is defined by g of x is equal to 16 minus x squared. State the range of g, right? So remember the range of g minus 1, and this is just 1 mark, right? The division method is confusing. Let me try and re-explain, all right? So f of x is 8x plus 5 over 2x plus 3, right? That's the numerator divided by the denominator, as a normal fraction is, right? So I'm just going to do that as a bus-stop division method, right? 8x plus 5 divided by 2x minus plus 3. Now I just need to see, I'm just focusing on the first term on the left-hand side, on the thing outside. How many times does 2x go into 8x? Well, that goes in 4 times, right? So I'm going to put 4 above that, and I'm going to subtract 4 lots of 2x plus 3, which is 8x plus 12, right? Just as you would when you're normally dividing. And if I subtract that, I get negative 7 left over, right? 2x does not go into negative 7 because you've got an x term there. So that is my remainder. So 4 is the integer amount of times. You have a remainder of 7 out of 2x plus 3. Coefficient method is easier. If you find that method easier, feel free to use it. This is how I did it, but whichever works for you, make sure you stick to that, all right? All right, so let's continue. So for part C, state the range of g to the minus 1. Looking at this, you should instantly be able to tell me what the answer is. Because if g of x is equal to 16 minus x squared, and it's given me the domain of x, is that thing, the range of the inverse function, remember, is the domain of the normal function. So I'm just going to write that out so you can see it in words. So the range of inverse equals domain of function, right? So therefore, the range of inverse g of x is 0 to inverse g of x to 4, because it's exactly the same as the domain in terms of x right there. Is it live or playable? I will be posting it on my YouTube channel as soon as I can. It just takes a couple of hours to export, but I'm gonna do it as soon as the live is over. I'm gonna save the video and upload it onto my YouTube channel. It has the same name, a user. All right, so you can go rewatch the live there if it helps. I hate domain and range. Honestly, kind of same too. The only bit I like is this question is nice, part C, because it gives you the domain of the normal function, while the range of the inverse is just the domain of that, right? Hi, joined for your live GCSE. Awesome, I'm glad the paper 3 went well, pal. I'm really glad it was useful. All right, you're done with maths now for GCSE. All right, so how do you even begin? Yeah, it is weird, but we roll, right? So hopefully this is making sense so far. Part D is the bit of the weird question, all right? So the method is kind of long. So they're telling me find the range of fg to the minus 1, all right? So D, fg to the minus 1. What am I doing? Well, I'm trying to find the range of this thing here. Well, I've got the range of g minus 1, right? So I have range for g minus 1 of x, right? So now I need the range of f of x, right? Well, I could just sub in 0 and 4 into f of x because that's my range of g, right? To see the maximum and minimum points of that, all right? So f of 0 is equal to, and if I just show you the f function again, that is my f function. So I'm just subbing into 8x plus 5 over 2x plus 3. So go down. All right, so that's 4 minus 7 thirds, which is equal to 5 thirds. And f of 4 is equal to 4 minus 7 over 8 plus 3, which is equal to 37 over 11. You're a very good teacher, you're explaining. Thank you, Taha, for the encouragement. Yeah, I'm going to keep doing this all the way through my uni, hopefully help out a bunch of people as well. All right, cool. So I'm just going to make a note of these fractions as decimals just for my reference here in brackets. So now I need to find where they overlap, right? I need to find where this overlaps with the range up here. Well, the overlap is just these values, right? because 1.66 is greater than the lower bound 0, and 3.36 is less than the upper bound 4. So where they overlap. So I found the range of inverse of G. I'm finding the range of F, and I need to find where those ranges overlap. Kind of like a simultaneous inequality, right? You need to find where both conditions are satisfied. So this is the greater of the lower one. So that's 5/3 is less than or equal to, and then that's just the same thing they gave in the question. The upper bound, well, it's either 4 or 3.36. Well, it's going to be 3.36. So less than 37/11. And that is how you would do this question. Alright. Sorry, 1 second. It's trying to get me to verify that I'm still on the live by dragging a puzzle piece. Alright. Sorry. I'm back. Let me just check the comments. Thank you everyone for following, by the way. I appreciate all the support. How big is the jump from grade 9 GCSE to first year level? The jump initially, Unit 1 is not too bad, but then it may seem a bit big, but if you just keep up with the work and do the exam practice questions, it'll be all smooth. Why'd you sub the values into f of x? I don't understand part D. Alright, I'm going to re-explain part D again, and this time like everything's on the screen, right? So, part C, I found the range of the inverse function of g, right? Which is 0 to g inverse of x is between 0 and 4, all right? Now I need to find the range of f inverse g. Remember, this is just a composite function, right? So I'm going inwards to outwards. So the range of the inverse function of g I already have is there, right? Now I need the range of f of x using the range of g, right? Because the range can only be between those values. Well, I'm putting g of x into f of x, right? I'm putting this into f of x, which is why I'm going to put the lowest value and the highest value of g into f of x and see what they give me, right? Because you're just putting them in. It's exactly the same thing as you've been taught, right? This goes into this. It's just that. So that's why I have subbed in 0 and 4 as my limits from g into that, all right? Then I get my two answers, 5/3 and 37/11. Now, I've not been asked to do that. I need to find the range of this composite function. Well, I've got the range of inverse g, and the range of f of inverse g is from this to this, right? This has got to be where they both happen at the same time, right? Because we need to satisfy both conditions for this function. Well, let's look at the lower bound first. The lower is 0 on that one and 1.66, which is 5/3 on this one. Well, which one is greater? This one, right? Because you need to have a greater lower bound. Then the upper bound. I've got 4 here. I've got 3.36 down there. Which one will satisfy both? If it's less than 3.36, which is 37/11, which is why we find where they overlap and that this is the range for f inverse g of x. I hope that explanation clear things up again. Remember, this is just a composite function, right? We're just putting one function into another, which is why I've subbed in the upper and lower of g into f. All right, checking. Awesome. I will be doing stats and mechanics next week in preparation. I haven't planned out the timetable yet, but I will be posting it on my account. Why not sub in the equation of g of x? And that brings me on to my next point. That is an alternative method. So I put it at the bottom, alternative. You can sub in the inverse g into x, and then sub in x equals 0 and x equals 16 as your limits, and then evaluate like that. All right? So that's how you would do it that way. This is Edexcel 2022 paper 2 A level. All right. So function domains and ranges and functions questions, we don't really like them, but just they all follow relatively the same thing. One thing I will warn you to look out for is if you've got two things being done to the x coordinate, all right? That because x is inverse, right? It's illogical, so you need to find the inverse of what you're doing to the x function, then apply that logically. That's how you do that. That's I think the last part of that, like the graph transformations is unit 2 of year 2. The graph transformation section is one of the last example questions they show. So that is what I'm just warning you guys, because they don't explicitly say to be careful of those, but I'm telling you, be careful of those types of questions. All right, let's move on to question 11. I'm just gonna give you guys 1 second to read this while I just have a drink of water. I am going through the whole paper and I will do a couple of questions from a paper I left off yesterday. I think there were 2 or 3 questions from that. So have a quick chance to read this. This question is a blessed question. I hope you guys get this question. I hate proof. Some proofs are long. They are difficult. But this is not too bad. So let's see how we can understand this type of proof. Does anyone in the comment want to say how they would do this type of proof? Bomb proof. All right. So prove using algebra that n times n squared plus 5 is even for all n. Even and odd, exactly. I'm liking what I'm seeing. Odd integers, even integers, right? So this thing here means that all positive integers, right? That's just all natural numbers. That's what that fancy n means. And natural numbers are 1, 2, 3, 4, 5, and so on. All right. So you can do proof by induction. I saw the mark scheme. It said you can do proof by induction, but that should be sent off for examiners, like a head examiner to check, I think. That's what the mark scheme said. But this one, I think you have to use proof by exhaustion. So the 2 things we can do in this are evens and odds, right? Proof by exhaustion. So if n is even, right, I'm going to write n as an even thing, right? What am I going to do to make it even? I'm just going to multiply by 2. N equals 2k. And k is just another letter, all right? We can always use algebra in this, all right? We can't use n because that's the letter given. Exactly. We're using a different constant where k can be any number. To make it even, just double it, all right? That's how it works. So if n is equal to 2k, I have n squared plus 5. That becomes 2k. And I'm squaring this, so this would be 4k squared plus 5. Remember to square the 2 as well, all right? So now I could just put the k into the bracket, so I have 2 multiplied by 4k cubed plus 5k. And look, I'm trying to prove it's even, right? So this whole thing in the bracket is being multiplied by 2. Therefore, even, because it's multiplied by 2, right? Because anything multiplied by 2 is even, all right? So I'm going to have to do the odd thing now, right? I haven't done the odd proof. So if n is odd, let n equal, so how am I going to represent an odd number? Well, an odd number is just 1 more than an even number, right? So n is equal to 2k plus 1, right? Because if I've got a number and I made it even, if I go 1 more exactly, I'm seeing the comments is looking good, it's just 1 more, all right? So now I've just got to sub in. I've got a bit more algebra to do for this one because I've got an add thing there. So that's equal to 2k plus 1. And then I've got 2k plus 1 whole squared plus 5. And if I just expand out, I have 2k plus 1. And this is going to be 4k squared plus 4k plus 1 plus 5 is plus 6. Sorry, my k's look a bit weird. I apologize. That's a thing. I'm not. Yeah, it's one of my faults. So now I need to prove this thing is even. I could expand the whole thing, then factor out a 2, or I could just notice that all of these are even, right? So I can factorize a 2 from this section here. So this would be 2k plus 1 multiplied by 2. And what am I going to have in the brackets once I factorize out a 2? 2k squared plus 2k plus 3, right? So this is just equal to 2 lots of 2k plus 1, 2k squared plus 2k plus 3. And now I can just say, therefore, it's even because I've multiplied by 2, because the whole thing here is being doubled. So therefore, it is even, right? Now, don't leave, I need to say this is super important. Do not leave your proof like this. You're not done yet. You need to have a final conclusion in your proof, okay? So you need to say that therefore, and just literally repeat what the question says, but this time in an assertive form, right? So n multiplied by n squared plus 5 is even for all natural numbers, or I'd say odd and even numbers. You need to say this conclusion step to get the final mark, because they will not give you the final mark to say, like, if you don't say that. So if you're ever doing a proof, do your proof, do all your workings, see what type of proof you need to do, and then just state what the proof has showed, right? So in this one, I'm showing that this thing is even for all positive integers of n. even and odd numbers, all right? Why not 3k? Okay, the reason we're not doing 3k for odd is because if k was equal to 2, 3k would be 6, right? That is an even number, right? We don't want that. We want to make sure any k we put in is going to make the number odd. So the way we do that is we know that 2k is always going to be even, right? If I go one more than an even number, it's going to be odd. That's why it's 2k plus 1, all right? Do I think 2025 paper 2 questions will be similar? Well, 2025 paper 1 was similar to 2022 paper 1, which I did on my first live. So who knows? It could be similar, right? We never know. But yeah, just always best to be prepared. That's why I'm trying to do this paper for you guys the night before. All right. So I'm hoping this is helpful so far. Further maths was similar to. Oh, was it? Wow. Okay, that's crazy. They're just being lazy, I guess. No, for Mars base case, 0 and 1, naturals 2k plus 1. Exactly, 2k plus 1. Okay, yeah. Alright. Cool, it says 2022 on the top left. Yeah, so that's just my little file name. Alright, so this is proof. Proof could definitely come up. Like proof, they love proof questions. The 2024 proof question at the end was weird. It was a weird proof. So just be ready for anything. This is a nice proof though, yeah? So, am I ready to move on? Let's move on to question 12 now. All right, this is where the questions start to get a bit more long for the like less number of marks, all right, or similar number of marks. So the function f is defined by f of x is equal to e to the 3x over 4x squared plus k, where k is a positive constant. Show that the f dash x, so that's the derivative, is equal to that, where g of x is a function to be found. All right, cool. All I gotta do is differentiate, and yes, quotient rule. So the quotient rule, I'm trying to write as fast as I can, but some of these words are so long, is, the way I remember it is vduv. V-do-u-v. But it's like, it's weird, right? So, and then by dx, vduv. That's like my way of remembering it. But I think it is given in the formula booklet. It's just given in function notation. So, the reason we know to do quotient rule is because we're having something divided by something, right? So it's a quotient. So, dy by dx is v du by dx minus u dv by dx. I need to make sure my u's and v's look different. I suck at that. Divided by v squared. All right. So that's my quotient rule. Now on the side, I just like to state what my things are. Then I just easily sub in, right? So u is the top number. So u equals e to the 3x. If I differentiate an exponential, remember you multiplied the whole thing by the coefficient of x. So that's 3e to the 3x. All right. So now I know that the denominator is v. V equals 4x squared plus k. So dv by dx is equal to 8x, because the k is a constant and k disappears, all right? Yeah, that's all. So now all I gotta do is nicely sub in. So what is v? Well, that's 4x squared plus k multiplied by du dx. Well, that's 3e to the 3x minus u, which is e to the 3x, dv by dx, which is 8x, all over v squared, which is 4x squared plus k whole squared. Okay? Now, let me just go check back to the question and see what sort of form they want it in. So they want it in the form where I have 12x squared minus 8x plus 3k, and I'm multiplying that by any function, all right? How am I going to get this thing here? Well, if I'm just reading through this, I can notice that 3 times 4 is 12, x squared, and then I'm multiplying the 3 by the k to get 3k. So this means that if I expand this and factorize it, I could get that first bracket, right? So I'm going to factorize out the e to the 3x first, all right? So e to the 3x, because that appears here and here is common, right? So then I have 3 times 4x squared is 12x squared. 3 times k is 3k minus 8x. All right, that's how I would do the factorizing on that bit. And it's over, and I'm just going to keep the denominator as is because I'm trying to find a function, and I already got the thing I wanted in the brackets right there, see? So all I got to do is just rewrite this in the order they wanted. So that would be 12x squared minus 8x plus 3k multiplied by e to the 3x all over 4x squared plus k whole squared, where g of x is a function to be found. So I just say where g of x is equal to e to the 3x over 4x squared plus k whole squared. So you see, this is why the reason I didn't cancel out that is because it's not divisible by it, and the question wants it in that form shown above, right? They want in the form where you've got this bracket multiplied by any function, right? So that function happens to be this obnoxious looking thing down here, where I've got e to the 3x divided by this whole big fraction expanded, right? And I didn't, like, you can expand it out and have that as your denominator, but there's not really any need. So we need to make sure it's in that form, which is why I have kept it and not factorized it out. 3 marks, but it's just a quotient rule question. I hope that makes sense so far. All right, let's do question B. So, given the curve with this equation has at least one stationary point, find the range of possible values of k. Okay, if it's got one stationary point, I know that this thing here is going to be equal to 0 at least once, right? So I'm just going to write that out. So if there's stationary points, f dash of x, which is equal to 12x squared minus 8x plus 3k multiplied by g of x. I'm just going to write g of x. I'm not going to write the whole function, and you'll see why in a second. Multiplied by g of x, if it's a stationary point, the first derivative, is equal to 0. So I know it's got at least one stationary point in it, right? Which means that this one also has at least one root, right? And now this has me thinking discriminant, right? I need to know the discriminant for this, right? B squared minus 4ac. If it's got at least one root, and as far as we know it's at least, it could be greater than or equal to 0. So I'm just going to sub in my discriminant there. So that's b squared, which is 64 minus 4, a is 12, c is 3k. Oh, look, I've got the k in an inequality. So that helps. And that is going to be greater than or equal to 0. So if I just expand this, that's 64 minus 144k greater than equal to 0. 64 greater than equal to 144k. K is going to be less than or equal to 49. So I just divided through by 144, swap my side around. So that is that. What I need to warn you for this is don't just say that that is your final range, right? You need to look at the question carefully. And I didn't underline it before, but I probably should have. K is a positive constant, and I need to make sure I use that fact here. I'm just saying K is less than 4/9, right? But K also has to be greater than 0. But K has to be greater than 0. Why? Because it's a positive constant. So therefore, 0 is less than K, which is less than or equal to 4/9, since it's positive. And we need to remember that. This is really sneaky of them to try and like get you to read that, because like most people would just move on from that, not notice that, and just state that less than 4/9 is their answer. But why not equal to 0 too? Well, because k is positive, so they don't really count 0 as a positive constant, and yeah, that's why. Yeah, that's like a bit of a little nuance there, but yeah. So that is how you do this question. I hope that makes sense. My advice from this is that read the questions very, very carefully, and if they ask you for a range of values, see anything else mentioned about that value, and make sure you take that into account in your range. All right, so that's how you do question 12. Gonna move on to question 13, which is a vectors question. Guys, let me know, did you do a vectors question in paper 1? I'm not sure if you did or not. And you can resit A levels. Yes, you can. All right, so you did a vector question. So I'm gonna go through this kind of fast then, all right, so I don't waste too much time. There was one at the start of the paper. Okay, so I'm guessing it was a relatively easy vectors question then. This one seems like it's a bit more involved. So I'm going to go through this, but I'm not gonna waste too much time, all right? And I'm gonna check the comments after each part just to see if there are any questions, all right? So I'm just gonna talk it through as I would do in an exam. So, part A. Relative to O, the point A has this position vector, B has that, C has that, where P is a constant. Where is P? There it is. Given that A, B, and C lie on a straight line, so they are collinear, find the value of P. Okay, so I know that they lie on a straight line, so they look like A, B, and C. So they've got a point in common. in common, and the vectors between them are all parallel. So I'm going to find the vector a to b, then a to c. I know that they are parallel. So AB, remember, is B minus A. So I is 0, J is 4, K is 6, minus the vector of A, 4 minus 3, 5. That's going to be equal to negative 4, 7, and 1. All right, cool. I'm going to find vector AC, and I have to use C because that is where P is. So I need to have that in my equation somewhere. So that is negative 16, P 10. I do it in column form because I hate IJK form. It's just easier to see this way. Then there's 4 minus 3, 5, and I get negative 20, and 10 minus 5 is 5. All right, so I know that since they're on same line, AC and AB are parallel or scalars. There are some scalars of each other, right? So this one looks like if I multiply by 5, I get that. So lambda lots of minus 4, 7, 1 is equal to negative 20p plus 3 and 5. So lambda is equal to 5, obviously here, because minus 4 times 5 is negative 20. So I know that lambda times 7, which is 35, is equal to p plus 3. And that just means p is equal to 32. That's how I do part A. Let me just check here. Any questions from this? Scrolling up. The vector asks us to find angle. Oh, angle vector question. Yeah, I hate those ones. Those are weird. I always hated vectors because of further maths. That one you just had to do cos of the angle in the direction divided by, I think, is the modulus of that direction. It's a weird formula. Column vector supremacy, exactly. Am I doing another paper? I'm not doing another full paper. I'm gonna do a couple of like the last 3 questions from the 2021 paper, I believe. I cannot do A plus B, no, because if I'm trying to find the vector from A to B, I'm gonna show you why it's this thing, okay? So if I've got O, imagine that's there, and I'm gonna go from A to B. Well, how can I go from A to B? Well, I can go from A to O, and then O to B. So that's OA plus OB. Sorry, not OA. It's very important I put this the right way around. AO, right? AO is negative of that. So that's like minus A plus B. Well, that's just B minus A. That's why I do B minus A for that. That's like the reasoning for that. All right, AB has the same grade as AC. Exactly. Why lambda? I just put lambda because it's a scalar, but like you don't even need to do this bit here. Like you could just see that you know that this is parallel to this, right? So how do you get from minus 4 to minus 20? You multiply by 5. How do you get from 1 to 5? Multiply by 5. So 7 to p plus 3, that's 7 equals, 7 times 5 equals p plus 3. That's how that works. So if the lambda throws you off, you don't need it. I just put it. It was like proof is a right angle. Oh, I hate geometric vector proofs. But yeah, you just need to find like 90 degrees, right? I guess, or 2 of the other angles and say the last one's 90 degrees. What have you written about scalars? Oh, over here, I just wrote that AC and AB are parallel, therefore scalars. I'm very lazy when writing words. That's what that bit means. Since on the same line, AC and AB are parallel, right? Because they're on the same line. They're parallel, right? Same direction, and they're scalars. I accidentally answered part B of vectors question part A. I wonder if still mark it. They tend to look at the entire question if there's a bit of reassurance. If you did it correctly and they can see the answer somewhere on that, and that is not contradicting, they may give you the mark. And then would it cost money? It depends on your check with your school about resitting. Yeah, labels, like if they see the answer somewhere, they have to mark it, right? They'll use their brains as long as you like lay it out neatly. The examiners have experience in this stuff. This is year 2 content because you've got why am I using my mouse? Because you've got 3D vectors. But the thing is, this could easily be a year 1 question because if you get rid of the k bit, you can still solve it. Like you just have one less equation, right? So year 1 knowledge, but year 2 vectors, right? It's not too bad. If you go okay, so I take that. Hey, vectors. Yeah, vectors already came up, which is why I'm just going through this real quick. All right. So let's do part B now. So part B, the line segment OB is extended to a point D. So that CD is parallel to OA. So CD is parallel to OA. Find the modulus of OD, write your answer as a fully simplified surd. So, well, I know that OD is still going to be parallel to OB. So that's lambda lots of OB, right? Again, this is just showing it's parallel and scalar. All right. So that is going to be equal to lambda lots of what is OB again? OB is 0, 4, and 6. 0, 4, 6. All right. So what do I need to see? They've told me CD is parallel to OA. So let's just find CD, which is D, which is 0, 4 lambda, 6 lambda, minus C, which is minus 16, 32, and 10. That's equal to 16, 4 lambda, minus 32, and 6 lambda, minus 10. All right. So because that's D minus C. All right. They've told me that that is parallel to OA. So I know that again, using scalars again, 16, 4 lambda minus 32, 6 lambda minus 10 is mu. This is just another symbol I use, is OA, which is this vector. So, okay, how am I going from 16 to 4? Well, mu is going to be equal to 4. So if I want to solve for lambda, that's 24 minus 10. Sorry, that's not 24. Make sure I use the correct Greek symbols. Hold up. So this would be 6 lambda minus 10 equals 20. So then lambda equals 5 because 10 plus 20, 30. 30 by 6, 5. All right, cool. So I know what OD is, right? So OD is going to be equal to 0 and then 4 times lambda, which is 20, and 6 times lambda, 30. Am I done yet with the question? Nope. They want me to find the modulus of OD. That's the magnitude, right? So the modulus of OD is just the square root of 20 squared plus 30 squared, just Pythag. And that's 10 root 13 as a surd, and that's how you would do that. All right, so let me just show the entire question and check the comments. Yeah, and there's exactly nothing stopping it from coming up again. Don't scare me, I hate vectors. Differential equations will definitely get me. Don't worry, I think, is it? All right, you're in luck. The next question is differential equations and rates of change. Not rates of change, but differential equations. How do you know what D is? Okay, so they have told me that D is an extended version of OB, right? So I know that D is going to be parallel to OB. So I've just represented O to D as sum lots of OB, right? So then that's my vector OD. And I need to find what OD is, so I need to solve for lambda. Then I'm like, okay, what am I going to do next? Well, I'll just see, have they given me any other information? They have. CD is parallel to OA. Okay, so I'm just going to write that out. Find CD first. So I do D, which is this in terms of lambda, minus C, which is equal to this thing over here. That is parallel to OA, which is 4 minus 3, 5. So I know that that is mu lots of that. The mu is just a scalar value again, right? Like lambda is a scalar, it's telling me by how much I multiply it. So is mu. Again, I don't need to include the mu. I could just compare them and see, okay, 16 is 4 times 4, and that means that I just needed that this is equal to 4 lots of this, and then I just solve the equation like that to find lambda. Cool, now I found lambda. What did I want to solve initially? OD. So if lambda is 5, OD is going to be 0, 20, 30. That's, I just multiplied that. But have I solved the question yet? Not fully. I need to find the magnitude of OD. So to find the magnitude of OD, I just do Pythagoras because it's going 0 across in the x, 20 across in the y, and 20 up in the z. So that's square root of 20 squared plus 30 squared, and that's 10 root 13. All right. Where the mu is just a scalar. I will be streaming until 8, but it's like until when I complete, yeah, I'll see how long I can go on before I get tired. D and C, the CD part is because of, it's telling me that CD is parallel to OA, right? So I'm just using the information given me and trying to see, is that gonna give me the answer I want, and just write down those marks. All right. All that. Yeah, honestly, this was what, 3 marks, right? 3 marks question, and the last mark is probably just from the magnitude. So yeah, all that for 2 marks. It is 2 equations. The tricky thing about this is knowing what to do, right? If you are stuck and don't know what to do, look at the information given in the question. So you've been given 2 pieces of information. This, so OB is parallel to OD, and this, CD is parallel to OA. Just use the information, see where that gets you, all right? I will be going live for Stats and Mechanics next week. I will post the dates on my page soon, like in the next few days when I plan it out. But yeah, so Stats and Mechanics, last bit of math for your A levels, guys. So yeah, I'd appreciate a follow if this is helpful. And yeah, so vectors could come up again. It already came up. How many questions in A level math? It's been a while. Roughly There were like what, 15 to 20 depending on how many marks. I have not done Kramer's rule. I'm very sorry. I don't know what that is. I've done matrices, like further maths, but I haven't done that. Sorry. All right, so let's do this. This question is a predicted question, right? Differential equations, okay? And I'm going to try and make this as easy for you guys to understand as possible, okay? That you are going to be excited, hopefully, for this question. And then I'm going to do another paper after this, like the last few questions there. There's a rates of change and differential equations there. So that's a bit harder. And I think I just posted a video, actually, on that. All right, cool. Let's do this. Express that as partial fractions. Okay, nice part A. So I know that 3 over 2x minus 1 times x plus 1. Well, I've not got any repeated factors on my bottom, so that's just going to be a over 2x minus 1 plus b over x plus 1. So I'm just going to stop that and on it again because there's a delay. All right, cool. So if I'm just doing this, I know that 3 is equal to a times x plus 1 plus b times 2x minus 1, right? Because I've just multiplied through by 2x minus 1 and x plus 1 on both sides. So I'm going to do the comparing coefficients method. No, not comparing. I'm going to do the substitution method. So I want to get rid of the a. So if x is negative 1, that'll get rid of my a. Oh, nice. That all just disappeared. I'm just going to write the last step I did there. Plus b 2x minus 1. So if x equals, oh my god, why does it keep disappearing? All right, I'm just going to show what I did before here. So if x is equal to negative 1, then I have 3 is equal to b times negative 2 minus 1 is minus 3. So b is equal to negative 1. Then I want to get rid of the b term. How am I going to get rid of that? Well, that would get rid of if x is equal to a half, right? So 3 is equal to 3a over 2. So a is just 2. So that is what it looks like when I'm expressing this in terms of partial fractions, okay? 2 over 2x minus 1 minus 1 over x plus 1. So that is what I'm just going to write here because this PDF keeps messing up with me and deleting my work. So that is annoying. All right, so in partial fractions, part A, I have 2 over 2x minus 1 minus 1 over x plus 1. All right, now I've got a lot of reading to do. I hate when math papers make me read because I just want to deal with numbers, right? So, when chemical A and chemical B are mixed, oxygen is produced. A scientist mix these two chemicals and measure the total volume of oxygen produced over a period of time. The volume is given by V meters cubed, T hours. So when you do these types of questions, you need to be careful of the units. So at the top, I just put units and underline where it is. So volume is in meters cubed, time is in hours, all right? So make sure you know the units that come up, okay? Is modeled by the differential equation, this thing where k is a constant. Given that exactly 2 hours after the chemicals were mixed, a total volume of 3 meters cubed of oxygen had been produced. So this is the thing in there. So at t equals 2, v equals 3. That's what I would write if I was sitting this question, all right? Solve the differential equation to show that v is equal to this. So it's given me the answer for 5 marks. I just need to show it, all right? So I'm just solving a differential equation. What is my differential equation thing? Here. So let's write that out. dv by dt is equal to 3v over 2t minus 1 and t plus 1. Now, notice I have split that already 3 over this thing on that side. So I'm going to bring all the v terms on one side and all the non-v terms on the other side. So if I divide through by v, I would have 1 over v dv. I multiply through by t, and I'll keep the right-hand side the same. 2t minus 1, t plus 1 dt. All right, the reason I've done that is because in part A, that is what I had as my fraction. So I'm just trying to get this bit so I can use my result down here. All right, and now I've got something dv, something dt. I can just integrate both parts. So this method is called separating the variables method. All right, so now if I integrate, well, first I'm going to tidy this up and write this in terms of partial fractions up here, right? So the integral 1v dv is equal to integrating 2 over 2t minus 1 minus 1 over t plus 1 with respect to t. Okay, so all I have to do is integrate these and this. So I'm going to use natural logs, right? So we should know that this is equal to ln v, and that is equal to, so this. I'm going to use the reverse chain rule. So I'm just going to say let y equal ln of the modulus of 2t minus 1, because I've got a fraction with the denominator and the numerator is like some scaled derivative of it, right? So if I differentiate that, I should get the integral, right? So that'll be over 2t minus 1, and using the chain rule, the derivative of this is 2. Okay, cool. So that is my y thing there. And now if I differentiate this, so let y equal ln of t plus 1. So dy by dt is equal to t plus 1, and that's 1. I don't want 1, I want negative 1, so that's going to be negative. So there. So ln v, I'm just going to write this down here. ln v is equal to ln of 2t minus 1 minus ln of t plus 1 plus c. Remember the constant, and you can put constants on both sides, but remember, a constant is a constant. If it's on left and right, just add them together and put that there. Let me just check any questions. Let's go up. Right, where? Wait, I don't get the 1 over v dv part. All right, so the 1 over v dv part is from here. I've divided both sides through by v. So that v goes down there, like it's 1 over dv, right? And I've multiplied both sides by dt. That's the separating the variables method. Because this thing looks like my part A. That's what I want, right? That's why I did that. Integrate using integrating factor. For this one, you don't need to because everything's being multiplied to each other. You mainly use that for like further math, first order differential equations. Yeah, exactly. But yeah, don't make it hard for yourself. If you like that though, go for it. Can you explain how the differential worked? So this one, right? So this is my differential equation up here, right? So we're happy with that. I need to solve this, right? And the way you solve differential equations for A-level maths is you get all the terms with v, the top letter, which is v, onto one side, and all the other terms with the other letter, which is t, onto the other side, and you integrate both sides separately, all right? So the reason I've just divided by v and not 3v is because if I look at my part A looks like this, right? There's a 3 in the numerator. That looks similar to this. So I've just done it like that. That's why I separated it that way, all right? Scroll up in quotient in ln. Yeah, I did partial fractions exactly. Can I do the yes? So that this. So I need to integrate 2 over 2t minus 1. I've got a fraction here, right? So I'm going to first think, can I do reverse chain? The numerator, if I differentiate the denominator, I'll get 2, right? Which is the numerator, right? It's a constant, which is why I've done ln of this. That's one of the standard things we should know, that if you've got a fraction, you just put the denominator in that, in a modulus, and then I'm just going to check, does that differentiate to give me the thing I want to integrate? It does. So that's something over 2t minus 1. Then using the chain rule, I differentiate 2t to get 2. So that's how it works there. So it'll be ln, that I don't need to scale that. Yeah, it is reverse chain rule. Why do I sound American? I have been raised in different parts of the world, but I'm British. Don't worry, I did A-levels. Yep, exactly. Dot 2 gave the explanation there. Good, nice. How come it's 2 ln? How come it's not 2 ln 2x minus 1? The reason it's not 2 ln is because, look, if I differentiate this, I get this, which is already what I wanted, because I'm using the chain rule to differentiate, right? So I differentiate the function, which goes something over 2t minus 1, then I differentiate the thing in the function. 2t minus 1, derivative is 2. That's why there's no 2 in the front. I don't need to scale it. All right. Awesome. And if it was 4, I would use ln. Exactly, I would still use ln if it was 4 over 2t minus 1, right? Because if I wanted 4 on top, well, I have a 2 here. So I'm going to scale this by a 2, which would mean this is my integral, all right? It's all about scaling and how that thing works. So you see what you have. Differentiate it, check, and then scale if needed. The only thing we scaled was down here where I had this, but I wanted a negative, right? So just multiply that by negative 1. So I multiply the y by the negative 1. Yeah, it would be yes, correct. So does this happen in general when you integrate? Yeah, this does. This is the rule for that. I think it's in year 2 integration, and it's in the reverse chain rule bit. So read through that, see how that works. And that. So yeah, if 4 was on top, you would get 2 ln t. Yes, exactly. That's what you get, right? Because you would just take the denominator and put it in ln. When you differentiate that, you get something over 2t minus 1. I'll differentiate this to get 2. Oh, I have a 2 here, but if I wanted a 4 over here, how am I going to get from 2 to 4? I multiply by 2. So I'm going to multiply this by 2, right? Because it's a constant. It's on the outside. That's how you would do it that way. All right? Awesome. I'm going to move on because I still haven't finished this, right? So I need to solve this differential equation. Show that v is equal to that. So I need to find C. How am I going to find C? I need some values given, right? Boundary conditions. Bam, there are my boundary conditions. So I'm just going to sub those in. So at T equals 2, the volume is equal to 3, 2 hours, right? So ln of 3 is equal to ln of 3 minus ln of 3 plus C. So therefore, C is equal to ln of 3. Shocker. So that means ln v is equal to ln modulus 2t minus 1 minus ln t plus 1 plus ln 3, because that is my constant, all right? So now I just need to tidy this up and get it in terms of v. I would have done 2 ln 2t minus 1. Still confused why it's not that. It's because you're doing the reverse chain rule, right? So if you take this and you differentiate it, you get that, right? So let me just, so it would be 2t over something over 2t minus 1. Using the chain rule, you differentiate this, you get 2, right? I already have a 2 there and I've got a 2 here. All right, cool. I don't need to scale it. If I had a 4 up there, then I would need to scale it. It's all scaled based on what the denominator differentiates to get up, all right? So I love all your guys is like each supporting each other in the chat. It's really good to see everyone helping each other out. All right, so now I just take it in the form of v, right? So I'm going to subtract this first using my log laws. So ln v equals ln big modulus 2t minus 1 over t plus 1 plus ln of 3, just doing one thing at a time. So that means that v is going to be equal to, and if I just add the logs with the same base, remember I multiply, so that's going to be 3 logs of 2t minus 1 over t plus 1. Big fat underline there. Is that my answer? Yes, it is. So already 5 marks in the bag, secured, okay? Now, part C is where they go on their, their difficult modeling bit. So the scientists noticed that there was a time delay between the chemicals being mixed and oxygen being produced, and there was a limit to the total volume of oxygen produced. Find the time delay in minutes and the limit in meters cubed. Now I'm just going to look at my units again. Remember I told you it's very important. Look, time is given in hours. So T is in hours. So I need to convert into minutes. It's very, very, very important you convert your units because that is a mark in itself that you don't want to lose because they won't give you the mark unless you get the exact units they want. So there's a time delay, right? So let's see when the volume is equal to 0, what is happening there, right? So when the volume is equal to 0, right? And I'm just going to put minutes on top so I don't forget. So when is the volume still going to be equal to 0? Well, that's going to be equal to 3 2t minus 1 over t plus 1 because that's volume, right? So this can just go away and that can also go away. So 0 is equal to 2t minus 1 because if I divide through by 3, the 0 by 3 is 0. And if I multiply by that, I get 0. And then if I just rearrange for t, I get t is equal to a half. But remember, that's in hours. I need it in minutes. So therefore, t is equal to 30 minutes. And that's how you do that, right? Because that's when the volume is still equal to 0, right? There is a time delay of 30 minutes. Can I go back to the previous form? Why is it when the volume is equal to 0? So let's think about it. So I'm just going to stay on this part if that's useful. So they've put in chemicals to produce oxygen, right? The chemicals still haven't mixed after 30 minutes to produce any oxygen. So the volume is still going to be 0 if there's a time delay, right? That's why it's that. It just takes a bit of like understanding, but yeah, for the 1 mark. So I'm going to do part 2 now. What is the limit? If you ever see a limit and it's in meters cubed, all right, cool. I don't have to do any conversions there. If you do limit, always just do as something tends to infinity. So here is the time, right? So as t tends to infinity, what is my volume going to tend towards? I'm just going to sub in increasingly large values of t. So in my calculator, I will put 3 multiplied by 2. Let's say t is 100 minus 1 over 100 plus 1, I'm getting 5.91. Now I'm going to make my t value 100,000, and I'm getting 5.9999. If I'm making it 1 million, I'm getting 6. It's all going to tend towards 6 exactly, right? So V tends towards 6. Let me write. Oh my god, my PDF is acting up. It's not letting me write the number 6. 6 meters cubed. So that is the limit, all right? So that is how you would do this question. So differential equations can almost y6. All right, so the reason is y6 is because there's a limit, right? So these chemicals are bubbling together for a long, long time, right? So if they keep bubbling as T becomes really, really big after a long number of hours, the volume is gonna have a limit, right? They've told me that. So I just need to see, yeah, trial and error kind of, right? So I just need to put in bigger and bigger values of T and see where does it kind of level off, right? So I put in T was 100, then 1000, then 1 million. In my exam, that's what I did too. And I found that eventually my calculator just gave me the number 6 in this question, all right? So I'm gonna do, I think I'm gonna do one more question from this paper, and then I'm gonna do some questions from another paper that I started yesterday. So this question is kind of sneaky. So I'm just gonna have it on the screen for a second while I just have a little drink. So where does it converge? Exactly, it's basically where it converges to. It's like the limit, right? Just keep going big, big, big T's and see where does it level off. All right. Hopefully this is helping you guys so far. So this question combines two topics in my opinion. It combines, as we can see, series, because it's telling me the first 3 terms of a geometric series is that. And it's obviously combining trig, because we can see a bunch of trig stuff there. Part A, show that this is an equation, all right? So I have to show an equation in terms of sine. Does anyone want to have a go and tell me in the chat what exactly do I do here? Like, because they haven't told me what I have to do to show this, right? What is the one thing I can do when I get given terms in a geometric series? What is their relation? Like, how am I going to go about this? Put them over each other. Exactly. That's exactly what you want to do, right? Because why? This is A, this is AR, and this is AR squared. We know that they all have a common ratio of R between them. So I know that the ratio from 5 plus 2 sine theta over the previous term, 12 cos theta, is equal to the ratio between 6 tan theta over the previous term, 5 plus 2 sine theta. All right. Now all I got to do is a bit equal fractions. Exactly. Divide third by second, second by first. Awesome. You all know what to do. So all I have to do is just rearrange this. So I'm going to have a lot of expanding and stuff. So I'm just going to talk to myself while I expand this. 5 plus 2 sine theta equals 6 tan theta times 12 cos theta. I could have just multiplied that there. Then I have 25 plus 5 times 2 is 10, plus 10 is 20 sine theta, plus 4 sine squared theta equals 72. And I'm going to write tan theta cos theta. Okay, so now I'm going to look back at the question and see what does it want me to show. It wants me to show it in terms of sine theta, okay? So I've got sines on the left side. I need to convert this into sine. Well, that should be not too difficult, right? Because we know that tan theta is equal to sine theta over cos theta, right? And I'm multiplying that by cos theta. So these causes just going to cancel, and I just get sine theta. So this would be, this thing equals 72 sine theta, and if I subtract 72 sine theta from both sides, I get 4 sine squared theta minus 52 sine theta plus 25 equals 0. And that is exactly what the question wanted me to show. 3 marks in the bag. Alright? I sound American. Oh my god. I'm British, guys. Don't worry. I promise. I did A levels. So, yeah. These are my exams. Not my exams, but exams I can do. Yeah, I'll try and sound. I'm a uni student. So, did my A levels year back, and now I am still doing A level papers. Alright. So, hopefully this makes sense so far. I'm trying to explain like things in a way that we understand, right? As students, that's like my little perspective on things. So hopefully my explanations make sense. I am studying computer science. Yeah. Little nerd over here. So, moving on to part B. Did you take 72? Yes, that's what I did in the last step. I subtracted 72 sine theta from both sides. Alright. Math. So this is perfect for you, direct math. I was gonna do math, but I was like, oh, good luck to you, man. I was gonna do math, but I was like, computer science is a bit of applied stuff, and I like applied stuff, so yeah, that's what I'm doing. Okay, cool. Moving on. Enough waffle. Given that theta is an obtuse angle measured in radians, so make sure your calculator is in radians. Solve the equation, find the exact value of theta. 2 marks. Okay, not bad. So all I have to do is solve this quadratic. The good thing about our calculators is we just need to do go into alpha mode, then find the polynomial solver and just put it in. So that's 4 minus 52, 25. So then I just get that sine theta is equal to 25 over 2 or a half. Now, I've got two answers, right? Which one am I going to use? It's a sine graph, right? Obviously, it's not going to be 12.5 because that is way bigger than the range of sine. It's going to be 1.2, right? So sine theta is equal to a half. So theta is equal to inverse sine of a half. I didn't mean to do 3 equals there. And that's going to give me pi by 6. But it is an obtuse angle, right? So if I look at my sine curve, obtuse is from 90 to 180, which is from pi by 2 to pi. Pi by 6 is over here. I need this one. So I'm just going to do pi minus pi by 6, and I get 5 pi by 6 as my answer. So that is my theta value there, 5 pi by 6. Because remember, it's obtuse, so you know it's between 90 to 180. And yeah, that's how that one works. Yeah, awesome. So show that the sum to infinity, all right, so I'm just thinking that of the series can be expressed in the form k1 minus root 3, where k is a constant to be found. Okay, cool. So I'm just gonna straight away try and get, like, just put down what you know. If you don't know what to do, just put what you know. So you know the sum to infinity formula is a over 1 minus r, all right? So we're happy with that. All we have to do is find a and find r and sub in. So a is my first term. What is my first term in this sequence? 12 cos theta. 12 cos theta. They told me theta was obtuse, and I found theta, which is 5 pi by 6. So that's 12 cos 5 pi over 6. And that's just going to be equal to negative 6 root 3. When I put that into the calculator, remember, you're in radians. So now I need to find what r is equal to. So I know that the ratio is that, right? I'm multiplying this by r to get this. So how am I going to do that? I'm just going to find what the first and the second term are. So the first term is minus 6 root 3. The second term in my calculator, I'm just going to put 5 plus 2 sine 5 pi by 6, right? So that's going to give me my second term, which is just 6. So if I'm multiplying by r, what am I multiplying by to get from here to here? Well, it's going from negative to positive, so r is going to be equal to negative something, and there's a root 3 here, but it's not there, so you're dividing by the root 3, and it's just going to be 1. So that is r. Now, all I have to do is sub into my formula. Nice and simple. Minus 6 root 3 over 1 plus 1 over root 3. Now, if I put that into my calculator, I get minus 6 root 3, 1 plus 1 over root 3. That gives me, 1 second, it's saving. That gives me 9 minus 9 root 3. Is that my final answer? Well, they factorize it and tell me I need to find k, right? So nice and easy, just factorize out of 9 minus 1 root 3, where k is equal to 9. And that is how you would do that question. Yes, so what I did there in my calculator was just rationalize. I rationalized the denominator to get that answer. That's exactly what you do. So yeah, so from, let me just make a note. So from here to there, rationalize. Yeah, because you had no denominator, you just had a numerator, and that's what you did there. All right, so that is this question. Hopefully that makes sense. I am going to switch papers now and go to a previous paper that I was doing yesterday, 10th, and it was A level, this one. So I'm going to do the last few questions from this, and they should be useful because they've got some parametrics, they've got a rates of change in differential equations, and there's this weird long trig question at the end. So I'm going to do these last 3 questions and call it a wrap unless you guys have any other questions. All right, so let me just get my solutions up and give me 1 second, please. Hopefully this is helping you guys and calming your nerves for your exam tomorrow. How are we all feeling? Are we feeling ready for this? Or question 13. All right, so let's do question 13 now. Scared. Yeah, honestly, it is. You feel cooked. Hopefully not after watching this. Like, I hope this has helped you a bit, right? But yeah, I'll be ready by tomorrow for sure. Exactly. Like, just don't pull an all-nighter. Like, make sure you have energy. Like, maximum 3 a.m. Okay, stay up till 3 a.m. max. Then go to sleep and wake up at like if you want 6 or 7. Do a bit of last-minute cramming and then go. Either question 13, 15. I got stuck on 14. What was 14? This one. Oh, don't worry. The video I just posted before this live, 4 a.m. max. Don't stay up too late though. You don't want to fall asleep in the final. So yeah, I literally just posted a video about this, and I'm gonna do this again on this live, so in case you guys have any additional questions. All right, cool. So 8. Well, let's get 8. My phone is on low charge, so I'm just gonna put it into charge so I don't die on you guys. This is the 2021, and this is the November paper, I believe. October paper. Yeah, this is 3 a.m. Y'all are crazy. I remember for my last exam was stats and mechanics, so I remember staying up very late, just like cramming it all. So I apologize that you guys are gonna be at an angle, but yeah, we're gonna do the last few questions of the paper I just started yesterday. I think October paper are resits. I'm not too sure about it, but it only makes sense, right? If the October and November papers are resits. All right, but I think you can resit them at normal time too, like now, like resit the exams in May, June time. Okie dokie. Let's start and finish off this paper. So, the curve C has parametric equations. Those are my equations. Find an expression for dy by dx in terms of theta. So that's not bad if we know how to differentiate parametrically. So if I want dy by dx, remember I can just find dy by d theta and multiply that by d theta over dx, right? Remember, using the chain rule. So October when people not happy. Oh, okay, that's why I was. All right, I see. Yeah, people are resitting now. All right. I hope it goes well for everyone, by the way. Best of luck. So I'm just going to find what these are, right? So I know that x is equal to sine 2 theta. So dx by d theta is going to be equal to 2 cos 2 theta. Multiply the function by the coefficient of theta, and then sine goes to cos, right? So then I have y is equal to cosec cubed theta. So dy by d theta, and this is in your formula book. I'm going to put a note up here. So d by dx of cosec x is equal to negative cosec x cot x. It's a weird thing. It's up there in the corner. All right, just going to zoom out. Sorry for the weird angle. All right, boom. Awesome. So that is going to be equal to, and remember I have to do the chain rule. So 3 lots of cosec squared theta reduced to power, and then I do the that differentiates to that, so I have negative, and then cosec, so that's still cubed, cot theta. All right, so that's the derivative. All I have to do is multiply those. So dy by dx is equal to that thing minus 3 cosec cubed theta cot theta over and 2 cos 2 theta, and that's it, because I took the reciprocal of that. All right, cool. That's how I do part A, parametric differentiation. You just differentiate both separately. Remember, parametric, you're basically doing the same thing twice. That's what it is at the end of the day. It is an ugly unit. I agree 100%. I didn't like it too much. But yeah, would it not go down to cosec squared? No. So yeah, here this differentiates to 3 cosec squared theta, but then I multiplied it by the derivative of cosec theta, which is up here. So I just did that all in one step. That's how I did that. They got rid of parametrics. Did they actually? Did they get rid of parametrics? That's crazy. Like the amount of hate they got. No, but you could do double angle formula and simplify further, right? You can simplify further. So they, yeah, this would be a. It would just be very messy because the double angle formula for cos has some addition things, and then you're gonna have 2 fractions, I think. But the answer just says this: find dy by dx in terms of theta. We've done it. Like, just leave it as is. All right. If you don't need to go on further, just leave it. All right. Check Excel spec. All right. just do parametrics, all right? Parametrics confirm not coming up, vector 6 markup predicted. Just do parametrics, okay? Like, if like it's in the textbook, do it, okay? Don't want to disadvantage yourself, right? It's better to do it and it not come up than don't do it and it come up. All right, cool. Part B, find the exact value of the gradient of the tangent to C at the point where y equals 8. So, in other words, I need the gradient, which is what? That is dy by dx at y equals 8. So I could just solve for theta, right? So 8 equals cosec cubed theta, which is, remember, cosec is 1 over sine, right? Because the letters switch. So 1 over sine cubed theta. So sine cubed theta is equal to 1/8. Therefore, sine theta is equal to a half. Cube root both sides. That's how you do it. So then if I wanted to find what sine was, so theta equals sine minus 1 of a half. That is equal to pi by 6. All right, so I just need to check that those are in between my limits, and they are, which is from 0 to pi by 2, so that works. This is like 30 degrees, that is 90 degrees, so it works. So now I just need to find the gradient at that point, right? Because I need to find theta for to sub in here. So dy by dx at theta equals pi by 6 equals, and this is what I'm going to put into my calculator, minus 3 bracket 1 over bracket sine pi by 6 all cubed multiplied by 1 over tan pi by 6 all divided by 2 cos 2 pi by 6. That is exactly what I'm going to put into my calculator. And because, the sine cubed theta is the same as sine theta whole cubed. And that gives me negative, let's just let it save, negative 24 root 3 as my answer, exact in a third. So that is how it needs to be in terms of theta. Don't simplify. Exactly. Don't simplify if you don't have to. You don't want to lose marks, right, for doing unnecessary works, because if your final answer is wrong, and that's the answer you give, you are not going to get the marks. So if you have answered the question and it matches what they want you to do in terms of theta, this is in terms of theta, 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 leave it as is, you get the marks. Bam, 6 marks. Parametric differentiation. All right. So I'm going to, there's no sine 2 theta, there's a sine 2 theta there, but we've differentiated that to get cos 2 theta, and then cos 2 theta is the obnoxious cos squared theta minus sine squared theta, right? And then you're going to have a bunch of fractions. We don't want to deal with all that. All right, now this is one of the most anticipated questions I've heard, a rates of change and differential equations question. How are you guys' feelings on this type of question in the chat? I just want to get a gauge for how we feel about this before I start and get right into it. Good, awesome. Hate, bad. All right, I am not great. Easy, good for. All right, good. We got a good mix. All right, we got a good mix. So I'm going to try and make it so that you guys love these type of questions. And I'm just checking my working. Damn, I used 4 pages for this working. So, okay, let's get right into it. So, take this. Horror. Oh my god. Okay, just follow along with me and it's not going to be hard. So, I got a diagram. Beautiful. Water flows at a constant rate into a large tank. The tank is a cuboid with all sides of negligible thickness. That's basically just saying that the side lengths are what they are in real life, okay? So we can ignore that. The base of the tank is 8 meters by 3 meters with a height of 5 meters. All right, cool on the diagram. There's a tap at point T at the bottom of the tank shown in figure 5. So yeah, it exists. At time T minutes, at the top, put your units, T mins. After the tap has been opened, the depth of the water is H meters. H meters. Alright, water is flowing into the tank at a constant rate of 0.48 meters cubed per minute. Water is modeled as leaving through the tap at a rate of 0.1 H meters cubed per minute. Show that according to the model, this is the equation. So, where do I start with this? The thing is, starting off is hard, and I'm going to be completely honest, I also hated these types of questions, rates of change questions. But the way you do it is just take it one bullet point at a time, all right? So, they told me, what is the first thing they told me? At T, the depth is H meters, all right? So I'm just going to make a note of that. at T, depth is H meters. Just so I understand the question, right? Now I'm just going to convert these, right? So it flow in at rate of 0.48, right? Which means that is plus 0.48. That is the rate of change of water, okay? Now it's flowing out at rate, and what is the rate it's flowing out? 0.1 H, 0.1 H. So that's subtract 0.1 H, right? So the rate of change of the volume is water, right? Because they're telling me water is flowing in meters cubed. So that is the change in volume, rate of change in volume, right? So rate of change of volume, okay? How do I represent a rate of change? Anytime you just see the word rate, it's dv, d something over dt. So here's dv over dt. And I know that the rate is changing as an increase of 0.48 and a decrease of that. So that's telling me my rate of change of volume, my dv over dt, is plus 0.48 meters cubed, and it's telling me per minute, right? It's giving me my time. Subtract 0.1 H meters cubed per minute. The reason is just those numbers is because they've given me my per minute. If they didn't give me my per minute, I'd need to find the rate of it by dividing by time. They'd give me another bit of information, and that's the number I would put in, okay? So this is my dv by dt. Do I want dv by dt? No, I want dh by dt, okay? So I'm going to put that, right? I want dh by dt. How am I going to get that? So I could multiply this dv by dt by dh for my numerator, and my denominator, I want to get rid of the dv, so dv. So this here is telling me I need an equation in terms of v and h, okay? So I need to make an equation that has both v's and h's, so I can differentiate that to find dv by dh. Are we following along so far? Hopefully this is making sense as I'm going as slow as I can. So I just need to find an equation for volume in terms of height. Well, I can easily do that, right? Because the volume of what? Volume of water, yeah? The volume of water would be equal to the base, which is 3 times 8, and the height of water at that time. So I'm just going to put that down here. So V is equal to 8 times 3 times H. I don't know why I put that in brackets. That's equal to 24H. So that just means that dV by dH, remember differentiate that, it's just 24. All right, now I want dV by dt, right? dV over dt. Sorry, I don't want dV by dt. I want dH by dt. dH by dt. I have dV by dt over there. I multiply that by dH by dV. So dV by dt is going 0.48 minus 0.1 H, and I'm multiplying that by the reciprocal of this, right? Because it's flipped, right? That's dV by dH. This is dH by dV. So I'm multiplying that by 1 over 24. All right? Now, let's see what I want. Look at your answer. I want an equation that has that, and I've got a bunch of numbers surrounding it too. Oh my god, it all went away. I'm gonna cry if this is all gone. I was doing so good. Okay, cool. Most of it is gone. That is delightful. So I'm just gonna show you the steps on my plan. All right? So here, this is my plan. So you can see we were over here, and I multiplied that by 1 over 24. If I now ignore this middle bit here, I'm multiplying this side by 24, and I just have that on the other side, okay? I forgot to put brackets there, by the way, my bad. So I need to have 1,200 dH by dt. So how am I getting from 0.48, which is my constant, to 24? I am multiplying by, okay, well, I've not done that first. How am I getting from to negative 5h? So I have negative 5h there, right? But I have negative 0.1h. I'm multiplying by 10, then I'm multiplying by 5, right? So if I multiply everything through by 10, I get this. Then I multiply everything through by 5, I get that. And notice that that is equal to the equation I want. So this step, this is technically a valid differential equation, right? But that's not what they wanted me to show. I wanted that. So just pick one of the numbers, negative 5h. Okay, I want negative 5h. I have negative 0.1h. How am I going to get from negative 0.1 to negative 5? Multiply by 10, multiply by 5. I could have just multiplied by 50, I'll be honest, but this is how I did it. Like, I was just, yeah, you know, when you're in the zone, you do stuff. That's what you get, and then you've proved that equation. So when you only multiply or divide across, all right? So yeah, that's how you do the rates of change. Does that make sense to everyone? I hope that kind of cleared up how you would do it. So I'm just going to put the answer here. Therefore, let me write. Therefore, 1200 dH by dt is equal to 24 minus 5h. All right, let me just check the comments. Unlucky. Yeah, it was unlucky. Oh, I know why. Differential rates of change, modeling rates of change. Yeah, awesome. All right, cool. Are we all understanding so far? That was so hard. It does take a bit of what we understand. Start over. Okay, so I'm just gonna give the explanation of this one more time. Check out my latest video I just posted. It's about juice. It's basically a similar question to this, but it's to do with juice. And see how I did that question where I made the rates of change. So they've given me information. The only way I can start doing this is by using the information they gave me. All right. So they've told me that water is flowing into the tank at that meters cubed. Look at the unit. That's a volume unit. Water is flowing out at that meters cubed. That is also another volume. So I know that the rate of change of volume, why is it a rate? Because it's per minute. Okay, rate is per minute, per time. So dV by dt is equal to, and I'm adding 0.48 in, and I'm taking away 0.1 h out per minute, right? But I don't want dV by dt, I want dH by dt. So how do I get that from that? Well, I need a dH and a dV to cancel out, right? So I need an equation that has an h and a v in it, okay? So how am I going to get an equation with h and v? Well, they told me that the volume is 8 times 3 times height, right? The volume of water, they've told me measurements. I can find the volume, right? That's what I just did. Volume is 8 times 3 times h is 24h. So dV by dH is 24. So now I can just find dH by dt by doing dH by dV, which is there, reciprocal, multiplied by dV by dt. Flowing out is negative, flowing in is positive. Exactly. So then I multiply that. I need to have brackets there. I apologize. I'm multiplying the reciprocal by that. This is just the chain rule, right? Now I'm just going to rearrange for dH by dt, so I can ignore this middle bit. I want an equation in terms of that, so I multiply through by 24 and I get this thing. That could technically be my answer, but they wanted to have this. So just pick any of these numbers and see how you get from your answer to this. So I picked negative 5h. How am I going to go from what I have, negative 0.1, to negative 5? I multiply by 10, then I multiply by 5, right, to get to that, right? I could have just multiplied by 50, but then once I've done that, I get this equation, which is what they wanted me to show. That is how you would do part A of the question. Check out my posted video after the live if you want another explanation, but I'm hoping that helps, right? Literally step one, use all the information they've given you, understand the units. So if it's a volume, it's going to be in meters cubed. And if it's a rate, remember, rate is per time. All right. So as long as you write down everything you know, you literally get marks, I think, as well for just saying flows in at a rate of this, flows out at a rate of that, and putting it as plus 0.4h minus plus 0.48 minus 0.1h. And then noticing that that's the rate of change of volume, right? So do what you know. Write down anything you understand from this and try and make a model, all right? How did I get dH by dV? So dH and dV, that has an equation in terms of V and H, right? So I just found the V equals, the volume is equal to 3 times 8 times H, right? Then I just differentiated that, 24H, derivative is 24, and then I just multiplied by 1 over 24 because that's the reciprocal. All right, cool. Volume of water, exactly. Now, we're going to move on to part B. I'm looking at my pre-notes. Wow, part B is long. All right, cool. Let's do it. 6 marks. Okay. Given that when the tap was open, so this is at t equals 0, I think, the depth of water in the tank was 2 meters. So h is equal to 2. Let me just see. Is that what I put on my notes? Yeah, awesome. Cool. Show that according to the model, h is equal to something where a, b, and k are constants to be found. All right, so I need to find a, b, and k. And this is a differential equation and it's solving for h, right? I'm just solving for h. So I have my differential equation here. All I have to do is find what h is, right? So let's do that. So I have part B. So I'm just going to rewrite this equation so I can, fully understand the equation in my head. Okay? I want to have all the terms with h's on one side and all the terms with no h's on the other side. This is now separating the variables. This is how you solve a differential equation in this form. So I'm going to divide both sides through by 24 minus 5h, right? Because with differential equations like this, in normal maths, you can only multiply or divide across. Further maths, you could use the integrating factor and all that, if there are any further maths in this, but don't do all that work. Like, literally just do it this way. It's much easier, all right? So then I'm going to divide through. I get 1200 over 24 minus 5h dh is equal to, and I'm going to multiply by dt across. So I just have like 1 dt. I don't like the way this looks, so I'm going to divide by 1200 on both sides again. So I have 1 over 24 minus 5h dh is equal to 1 over 1200 dt. Notice I have my h terms on one side and my non-h terms on the other side, right? This could easily integrate to a t term, right? So all I have to do is 2 sets of integration. Awesome, so let's do it. So how am I going to integrate this? I'm going to use the reverse chain rule. So I'm just going to say, oh my god, oh no way. Alright, I'm going to write down the last step so we have that there. I'm going to cry. 1 over 24 minus 5h is, with dh is equal to integral of 1 over 1200 dt. I apologize, guys, that it went away. I hate when this does this. You know, it sucks when I'm revising and it all goes away and I don't even have my reference. So, reverse chain rule on both. So, let y equal, and I just take the natural log of the denominator. That's what you do, 24 minus 5h. So, dy by dh, I'm going to differentiate that. So, it's going to be something over 24 minus 5h, chain rule. If I differentiate this, I have minus 5 up here. I don't want that. I want a 1, right? How am I going to get rid of that? I'm going to multiply by 1 over negative 5. So this would be negative a fifth. This is what this integrates to, all right? So now I can integrate both sides. So I have negative 1/5 ln of the modulus 24 minus 5h. Honestly, Excel is against us. I am in uni. I'm not in year 13. I did my A levels last year. So that is going to be equal to, and how am I going to integrate this? Well, that doesn't have a t, so I'm just going to put a t there, right? 1 over 1200 t. Divide through by 1 is the same thing, but remember your constant plus c. You just need one constant. I like to put it on the right hand side because it just looks more comfortable that way, I'll be honest. So I have this. I want to solve for h, but I have a constant. How am I going to find what my constant is? Use a boundary condition. So if I just scroll up to the boundary condition they gave me, they told me when the tap was opened, the depth was this. So at t equals 0, h equals 2. Wait, can you explain that part again? Why didn't you integrate? I did integrate the right. Sorry if it doesn't look clear. So I want to integrate this and this, right? So to integrate this, I'm using the reverse chain rule. Why? Because I've got a fraction where the denominator is, like, if I differentiate that, the numerator is some scaled version of that, right? So I'm going to let y equal ln of the denominator. And if I differentiate that, I get something over the denominator, and I differentiate this, I get minus 5 using the chain rule. I don't want that negative 5, right? I want a 1 there. How am I going to get rid of this negative 5? Well, I'm going to multiply by 1 over negative 5. So if I multiply that by 1 over negative 5, I multiply my y by 1 over negative 5. So this is how I integrate this left-hand side there, all right? The right-hand side is 1 over 1200 with respect to t. If I integrate that, I increase the power of t by 1, so it's just t. And that's literally it, all right? So that's how you integrate the right-hand side. Because there was no t, now there's a t. And I have to put a constant, plus c. All right? So I need to find what that constant is. So at t equals 0, they told me my height is equal to 2. So I'll just sub in. So minus 1/5 ln of, this would be 14, is equal to c. Awesome. Well, that's just what c is equal to, right? So that means my equation is now minus 1/5 ln of 24 minus 5h equals 1 over 1200 t minus 1/5 ln of 14. I've ignored my modulus sign because 14 is already positive, right? So what am I going to do from this stage? I will need to get all my ln's onto one side, right? Let's just tidy that up first, right? So if I put my ln onto this side, I'd have 1/5 ln of, and I'm going to factorize out my 1/5 now, actually. ln of 14 minus ln of 24 minus 5h is equal to 1 over 1200 t. All right, so that's what I did there. I literally just added this onto here and factorized out the 1/5. So I have just ln's in that. All right, so now I could multiply both sides by 5. So this would be equal to 1 over 240 t. And I can evaluate this natural log using my log laws, right? So if I'm subtracting, I do the first divided by the second. So this is ln of big modulus 14 divided by the second log thing, and I get that, all right? So let me just in the comments. Never getting this. Oh, come on, you can't get this. Like, this is, like, it's long, but okay, what I advise if you struggle with this, do the solving differential equations. They're like 6, 7, 8, 9, 10 marks in the year 2 book. Do a bunch of those questions, all right? And then you'll be ready. So easy to mess. Yeah, they are very easy to make silly mistakes. That's why the numbers they give don't tend to be overly difficult. Like, these are rounder numbers, I'd say, like no decimals, but you could. Like, just, yeah, be very, very careful. Did you get minus 1/5 because the denominator differented to said value? Yeah, here. I got the 1/5 because, yeah, I didn't want that negative 1/5 there, right? So I wanted a 1. How do I get from that to a 1? I multiply by 1 and I divide by negative 5. So that means I multiplied the y bit there. That's my integral. All right, cool. Moving on. All right, cool, cool. I love saying that phrase. Cool, cool. So how am I going to get from this to an actual equation? Well, this is e to some power is equal to that. Well, the power is that. So this is e to the power of 1 over 240t is equal to 14 over 24 minus 5h. All right? Do you guys understand how I did that step there? This is just me evaluating my log, right? Like a anti-log, I think it's called. Where did I get the 1 over 1200t? I integrated the right-hand side, which is 1 over 1200. That integrates to 1 over 1200t, right, with respect to t. All right, exactly. ln not cancels, because there's no ln on this side. I've raised it, right? Because the log, right, what does it tell me? E to some power is equal to the thing there. That is my power. So e to that power is equal to the big thing in the log. All right? Okay, PDF is again annoying me. Let's just hope this doesn't disappear. If it does, I'm actually gonna crash out. Alright, so now, bro, you forgot the plus D. Plus C. I didn't forget the plus C. Notice, on the top of the page, I put the arrow there, right? I did the plus C, and then I solved for it using my boundary conditions. So there, my plus C, my C is that. So this has become my plus C. Alright, do you guys see how? How do I integrate? X squared. You increase the power by 1, so that's x cubed, and divide by the new power, so that's 1/3 x cubed. Alright, cool. So, are we happy with this so far? Now my mouth is getting dry. Alright, so now, what do I have to do here? Let's look back at the question, see what form they wanted in. No worries, man. Alright, so they wanted h equals a plus be to the minus kt. It's very small, but that's how they wanted the initial form, right? So they want an exponential with a negative k, and they want just h alone, alright? So what I can do is I'm going to multiply by 24 minus 5h onto both sides. So this is going to look obnoxious. I apologize, but this is what you have to do. 24, oh, no, that's not right. 24 e to the 1 over 240t minus 5h e to the 1 over 240t is equal to 14. All right? So now I'm going to rearrange and just get this h thing onto one side. So 5h e to 1 over 240t is equal to, I added that there, so I'm going to subtract 14 from both sides. 24e 1 over 240t minus 14. All right? So that's the only thing I could logically do, right? Multiply through and rearrange to get h on one side. Okay, now what am I going to do? I just want to separate the 5 and this from the h, right? That's all I have to do left. So I'm going to divide by e to the 1 over 240t from both sides. So I get 5h is equal to, well, that just becomes 24. Is that what it becomes? Yep, 24 minus 14 over e to the 1 over 240t. Now I want to get rid of that 5. So again, I just do the inverse of it. So it's multiply, so I divide. So therefore, h is going to be equal to 4.8 minus, so that's 24 divided by 5. Now I'm doing 14 divided by 5, which is 2.8. And because I have the e on the denominator, how am I going to get this to the numerator? Well, I just put that to a negative power and bring it up, right? That's e to the minus 1 over 240t, right? And this is my answer, all right? So k is equal to negative 1 over 240. K is equal to 1 over 240. You can see you've got a negative power there. That's the form they wanted it in. Damn, that was a lot of talking, but that's 6 marks. All right. So you should explain integral f dash of x over f of x to chat. This struggle with it. Sorry, my mind is I'm a bit tired. Which step was that? The integral f dash of x over f of x? Oh, the reverse chain rule. The reverse chain rule, right? Okay. I am going to, oh no, I hope this didn't rub out. I hope this did. Oh, thank God. Thank God it's still there. This is the 2021 A-Level Paper 2. All right, so I'm going to explain the reverse chain rule real quick, okay, using this example. So, this. So, if I want to integrate 1 over 24 minus 5h with respect to h, okay? How am I going to integrate this? So my top tip for recognizing how to integrate something that looks like this is, number 1, this is a fraction, right? So I see a fraction, I think, okay, can I like split the fraction up? Well, no, not really here. I see a fraction, I think, can I use the reverse chain rule, right? So the reverse chain rule with a fraction tells me that let y equal to ln of the denominator, all right? So here my denominator is 24 minus 5h. The reason I know I can use the reverse chain rule is exactly as the comment says. If I differentiate the denominator, I get minus 5, right? Minus 5 is a constant, right? The numerator is also a constant. Because they're both the same type of number, I'm allowed to use the reverse chain rule because my denominator differentiates to some scaled version of my numerator, right? But let's say this was h, all right? If that was h and this differentiated to minus 5, I would not be able to use the reverse chain rule because this is not some scaled derivative of that, all right? So that is why I'm using the reverse chain rule. So now I just need to check, does this thing I've let y equal to actually differentiate to give me that? Because remember, differentiation and integration, they're opposites of each other. So dy by dh should give me this. I'm praying I get that, right? So remember, ln, differentiate, that becomes something over the function. And I use the chain rule, so differentiating that, I get minus 5. All right, I don't want this minus 5. I want a 1, right? So I'm going to multiply by something over negative 5, just 1 over negative 5, right? So if I'm multiplying my derivative value of that, I'm just going to multiply multiply my y by that. So that's minus 1/5 ln, let me write, ln of 24 minus 5h plus c, right? So that's how you do that, okay? This is reverse chain rule. It's in the textbook, so make sure you do some practice questions if you still struggle with that, all right? Practice, practice, practice. That's all I can advise, all right? So now, is there any more to this question? Awesome. Part C. Given that the tap remains open, determine, according to the model, whether the tank will ever become full, giving a reason for your answer. So this is a 2-marker, right? It's a worded 2-marker. That means you have 1 mark for doing some maths as well, right? You just won't get the answer, right? So given the tap remains open, that means as time goes infinitely onwards, as t goes on, right? What is happening here? E to the minus 1 over 240 t, right? That's the only bit with t there. What is happening to that? Well, that is going towards 0, right? Because as t gets bigger and bigger, you're doing a negative value of e, and that's just going to go closer and closer and closer to 0, right? You can put this into your calculator and sub in any t values and keep going bigger. You're going to get 0, right? So that means that h tends towards 4.8, right? Because if I multiply 2.8 by 0, that goes away. So h tends to 4.8. So that's what my height could become if the tap remains open. Now, does that mean that this tank will ever become full? Let's check. What is the maximum height of this tank? So I'm going to go back up to the beautiful picture and see, damn, that the height of this tank is 5 meters, right? It's only going to go up to 4.8 meters in total. So then I just say at the end, and the hint for this is you still haven't used this 5 meters. That's the only value left you haven't used. So use it, okay? So you'd say the tank is 5 meters high, but it limits the h, like the height, at 4.8. Therefore, it'll never become full. All right? So that's why you do that. That's how you do that last part, all right? So notice we didn't use the fact that the height was 5 in the diagram, right? So that's why we used it here, right? So if you don't use a value, it's probably going to be used at some point. All right. I hope that this question doesn't seem too impossible now, and I hope you guys can get as many marks as you can from this. But yeah, I'm seeing the comments in the chat. Yep, you're all like, you have to group the same symbols together. Can you go back to the end of part B, please? End of part B. Oh, that's the here, right? All right, so if you guys want to take a screenshot of this, you can. But yeah, this is how the end of part B looks. You've got a bunch of logs. I'm just putting in my boundary conditions over here, and then to find my constant, because remember plus C, put that in. I need what? I need in terms of h, right? So I'm just going to rearrange, get the logs on one side, then I can do e to some power, which is that, is equal to this. You have that, then you're like, okay, where do I go from that point? Well, the only thing I could do is just multiply there, get my h's onto one side, and then I want to get h alone, right? All I have to do to get h alone is divide by 5e to the 1 over 240t. I did that in 2 steps, but then once I divide through by that, I get the answer they wanted, and I just noticed that e1 to 240t, if I make this a negative power, I can bring it up, which is what they wanted in the question. How'd you get h from 5 in the how do you get what C is? Okay, I'm going to answer the questions in order. So how do I get what C is? Well, I need to use boundary conditions, right? They have told me in the question, where is it? There. Given that when the tap was open, that's T equals 0, the depth of the water and the height is 2 meters. Notice H is in meters, right? So that's why H is 2. So then I just put in my T equals 0, H is 2. So if H is 2 there, that's ln 14. And T is 0, that goes away. That's plus C. That's how I get my constant, and I put that on there. And then is 5H, not 5K. The reason for the part C is, notice that the height is 5 meters. That's how big my tank is, right? But I noticed that my limit was, long question. The limit, H would go towards 4.8 meters, right? That means it's never gonna get to 5 meters, right? As time goes infinitely onwards, right? As t tends to infinity, plug in super big values of t into that, you're gonna see that that goes away. So the height is gonna tend towards 4.8, and it's never going to fill. These last couple of questions are long. Exactly. Like if you think you're doing good for time in those, don't be complacent. Like in the earlier questions, like these, super quick. Don't be complacent. Keep like pushing it to the very end, because the last question is worth a lot of marks sometimes. Like this one, dude, this one is worth, I'm not adding that, 11 marks. That's a tenth of your paper. That could be a whole grade boundary. So you need to make sure that you have enough time to do them, because they're longer, but you have less time. They're longer, but you have the same number of marks. All right, cool. This question is not actually too bad. So my handwriting default for is confusing. All right, so we're gonna do this last question, and I'm gonna wrap up the live. So express. So part A is nice and simple because there's no modeling in that, right? Express 2 cos theta minus sine theta in the form r cos theta plus alpha, where r is greater than 0 and alpha, those are the limits. So just remember the limits. Find the exact value of r and the value of alpha in radians to 3dp. So make sure your calculator is in radians and you need to round. All right, this is just asking me to put it into the form r cos theta plus alpha as a harmonic form. So the way you do this is you use your addition rules. Can I put this landscape? What happens if I do it this way? Nope, it just becomes long. All right, I'm going to be doing a lot of up and down scrolling for this question, okay? So A is equal to, so question A, the equation they gave me was 2 cos theta minus sine theta. They want it in the form of r cos theta plus alpha, right? So I'm going to use my cos addition law, okay? So that's r cos theta cos alpha. Remember, because we're adding, the cos law says it's minus r sine theta sine alpha. And remember to multiply both things by r, okay? So r is not the square root of 3. It's not. You'll see why. So I'm gonna just say that I've got my cos theta there and there's a cos theta there. So I know that 2 is equal to r cos alpha. I have my sine theta there and a sine theta there. So I know that 1 is equal to r sine alpha. I just ignored they're both negative, so I don't need to do that. So if I divide both things, if I do this divided by this, I'd have tan alpha, right? Because sine alpha over cos alpha is tan alpha, and r by r, they cancel. That is equal to a half. So alpha is inverse tan of a half, which is equal to 0.464 radians to 3 decimal places, all right? They asked a 3dp? Yep, all right? So that is my alpha value done. Now, I could sub in this alpha here and find what r is, but when I did that, it didn't give me an exact answer, and that was, kind of annoying. So how am I going to get an exact answer? Because that's what the question tells me. Well, r is just the square root. R is the square root of a squared plus b squared, where a and b are the coefficients of cos and sine, okay? So the square root of 2 squared plus negative 1 squared is equal to root 5. So that is r and that's alpha, so I'm just going to rewrite my equation as root 5 cos theta plus 0.464, and that's how you do that. So that's why it's not the square root of 3. So I hope that makes sense. It's crazy how much good random people online. I'm glad it's helping you guys. Yeah, feel free to follow if it is useful. I'd appreciate all the support. All right, so now that was the easy part of this. All right, I subtract instead of adding. I had a feeling. Yeah. So now this is where the modeling bit comes in. So don't be put off by the models. Okay. So I've got a big fat wheel here, and it's telling me figure 6 shows a cross section of a water wheel. They've had a lot of water-based questions in this exam. The wheel is free to rotate about a fixed axis through the point C. This basically just means it's rotating in one axis. So imagine like this is the wheel, it's rotating around like this. It's not going off at an angle like that. All right, that's just what it means. All right. The point P is at one end of the paddles of the wheel as shown in figure 6. So there's P over there. Beautiful. The water level is assumed to be horizontal and of constant height. So yeah, the water wheel is in the water. Group of random students greater than teachers. Yes, because I understand like what we don't know, right? I'm also like still a student. So I know what we struggle with and I try and teach myself, right? So yeah. The vertical height, h meters, of P above the water level is modeled by this equation. So notice we've got another trig equation where T is the time in seconds. So note the units. H is in meters and T is in seconds. Use the model, find the maximum height of P above the water level. So let's just do that first. So part B, I. Well, first I'm going to compare the equations. So I'm just going to do B generally, okay? So the equation so I know that 2 cos theta minus sine theta, I'm going to rewrite this to make it clear. 2 cos theta minus sine theta, well, I know what that is in an easier form, square root of 5 cos theta plus 0.464. That's what I've done in part A. So I have to use that in part B, okay? So I'm going to compare and look at the equation in part B. H equals 3 plus 4 cos 0.5t minus 2 sine 0.5t. So I'm going to see how am I going to get from that to this? Well, that's 3 plus 2 lots of 2 cos 0.5t minus sine of 0.5t. That's how I put this equation into this. All right. So I've just split up that 4 and that 2, factorize out the 2, and put it there. Okay. So now I can just replace this obnoxious looking thing with this simple thing up here and just solve it with like one trig function. So that's equal to 3 plus 2 root 5, because that's 2 times root 5, cos of 0.5 t, because now theta is 0.5 t. Notice that difference. Plus 0.464. Okay? Now, that is my equation in terms of harmonic form. The maximum height, max height, I'm hoping everyone here knows what to do when they see the words max height. Maximum height is when cos of this thing, I'm just going to call this x, cos of x is equal to, what's the maximum value of cos of anything? 1. So the maximum height is when that's equal to 1, so that's going to be equal to 3 plus 2 root 5 meters. So that is the maximum height, all right? Now let's look at what part 2 says. I have a feeling part 2 is about time. It is. Find the value of t when this maximum height first occurs, giving your answer to 1 decimal place. So I'm basically being asked, part II, when is cos of 0.5t plus 0.464 equal to 1, right? So if I just do my inverse cos, I have 0.5t plus 0.464 equals inverse cos of 1. So that will give me 0 and 2 pi. Now I need to think which of these is my most valid answer. I'm going to look at my cos graph, and I'm being told that these are my cos values, right? I'm solving for 0.5t plus 0.464. Let's continue and see which of these solutions is valid, okay? Because there's only one solution. So if I keep solving for 0, I'd have 0.5t plus 0.464 equals 0. And if I subtract this from both sides, I'd have 0.5t equals negative 0.464. So t is going to be a negative answer, but it's not. T cannot be equal to 0. It's not a negative value, which is why I'm just focusing on 2 pi. Does that make sense, guys? That's why exactly, if you use 0 time, it will be negative, which is why I'm not going to do any working with that, okay? Because I'm solving for t, not 0.5t plus 0.464. So now, if I solve for t, I have 0.5t equals 2 pi minus 0.464. So let me just say, all right, so t is equal to 2 pi minus 0.464 divided by 0.5, and that is equal to 11.63 dot dot dot. I just put a couple more decimal places before I round, just so they can see I round. So that is going to be equal to 11.621 decimal place, which is what they wanted. And that's how you do part B of that question. All right. So does that make sense, guys, for part B, part I and II, part 1 and 2? So remember, maximum and minimum values. If it's 1 is max, that's the whole costing. One thing I need to warn you guys about, if I was doing multiply by negative cos theta, the maximum would occur when cos theta is equal to negative 1, right? Because I'm multiplying a negative by a negative, right? So just be very careful and just check. If you're multiplying by a negative, it is going to be equal to, is going to be max when cos theta is equal to negative 1, all right? So far, this is not a bad question. It's exactly like a textbook question, right? This is dream question. Yeah, it is easier than a lot easier than the other question. It's weird. I don't know why they put this in the middle of the paper, right? You'd think question 14 is the last question, but no, this is the last question. Nice little trig question. Okay, cool. But we're not done yet. There's a 4-marker question coming up. So, in a single revolution of the wheel, P is below the water level for a total of big T seconds. According to the model, find the value of T, giving your answer to 3 sig figs. I don't have to be too cautious here because they haven't told me find T in like minutes, because small t is in seconds. So yeah, and yeah, this is TikTok records this live, so I have a YouTube channel, same name, a user. So I'm gonna post this as soon as I can after the live is done. It does take a couple of hours to export though, so I'm going to do it as fast. If cos was in a fraction, would the max be equal to negative 1, 2? So those ones you have to be careful, right? So the maximum would be when the fraction has the smallest denominator, right? So it depends. Negative signs would affect the cos, like if it was negative 1 or positive 1. And if you had a fraction, it would affect the magnitude of the value, all right? So I will post as soon as possible. I'll try my best, right? So we are just going to finish off this last question. So I need to find the value of t, where t is where the wheel is below the water level, right? So where is the water level? Well, the water level, I'm going to set that's 0, right? So part C, the water level is equal to 0. So what is my equation of the wheel? The equation is 3 plus 2 root 5 cos of 0.5 t plus 0.464, and that's equal to 0. I want to find where that is equal to 0, right? So if I just rearrange this, and I'm going to subtract 3 on both sides and divide by 2 root 5, I get cos, I'm sick of writing this, 0.5t plus 0.464 equals negative 3 over 2 root 5. And I'm going to solve for this thing. So again, 0.5t plus 0.464. Make sure you write the whole thing, or like you could just say that x equals this thing to speed it up. This is October 2021 paper 2 A-level at Excel. That is equal to inverse cos of minus 3 over 2 root 5. And now I'm going to solve for this. So I get, I'm going to put this into my calculator, minus 2, 3. I've already got this on my plan, but I want to do it myself again just in case. So 2.3061, blah, blah, blah. Okay? I'm solving for t, guys. Remember, I'm solving for t. So I'm going to store this exact answer in A, right? So I'm going to press store on my calculator, which is just above the number 7. I'm going to press A afterwards. So that value is stored in A, okay? So I put that in A. Now I'm going to find the next time where it touches the water level, all right? So if I look at my cos graph, I'm going to find that, okay, there's two solutions. So I'm doing 2 pi minus A, right? So if I just put in my calculator 2 pi minus alpha A, I get, it's very dark, 1 second. I get 3.977, blah, blah, blah. I'm going to store that as B in my calculator. So now I need T, okay? So 0.5T is equal to, I'm going to subtract 0.464 from these values, is 1.842, so on, and I'm going to store this as C. So this, I'm now just subtracting 0.464, and if I subtract from the other one, I get 3.513, and so on. I'm going to store that as D, all right? So now, I just need to find what T is. The T is going to be 2 lots of C and 2 lots of D. This time is afterwards, and this time is before, right? So what am I actually solving for? Let me go up and remind myself again. So T is the time taken while it's below water level. So I'm going to do the time where it leaves the water minus the time where it enters. So T is going to be equal to 2 lots of D minus 2 lots of C. If you are using D's and C's in your exams, I wouldn't do that. I like do it how I'm doing, putting the letters underneath. But here, just put 1.842 dot dot dot. Don't do C's and D's all the time, just in case you forget what they are, okay? This helps remind you what the number is. So if I do 2 times 3.513 minus 2 times 1.842, I get 3.34 seconds. And that is my answer right there. Why is it 2 lots? Because here I have 0.5t, right? That's the same as writing t over 2. So if I want just what t is equal to, I multiply both of these by 2. So I've just doubled up my steps there, so I have less steps to do. And I do 2d minus 2c. That's why it is. All right, awesome. I don't think I'm done yet. I think there's another part of this question. Yep, there is. Awesome. The 1 marker. You know, it's the modeling 1 markers that we all hate. So, in reality, the water level may not be of constant height. Well, it probably, yeah, that's what it is. It should be D minus C. It's not D minus C because I set my D and C values before I multiplied by 2. So notice, T over 2 is C and D. But yeah, why do I have 2 cos values? Well, because I'm trying to find, so it's told me in a single revolution, P is below the water level for a total of T seconds, right? So imagine this water wheel is underneath. It enters at one point and it comes out at another point. That point is where the water level is equal to 0, right? So that's why I set it equal to 0. I found where it enters and where it exits. So yeah, that's why you have 2 cos values, right? So 0.5t is equal to these. I need to just find what t is equal to. I need the times, right? Oh yeah, no worries, Bryn. So, sorry if I made that a bit unclear. So then I have t over 2 is equal to that by subtract. I didn't mean to put divide. That is my bad. That is meant to be subtract 0.464. And then I just double them because I have 0.5t. and that's how you get what your t-values are, and the duration is under is when it leaves minus when it enters. All right, let's look at the dreaded one-mark modeling. So it's not of constant height, right? So explain how the equation of the model should be refined to take this into account. I'm going to do this up here. Let's see what it does. So the model shows that the height of P above the water level is 3 plus 4 cos that minus that, which we said is H equals 3 plus 2 root 5 cos of 0.5 T plus 0.464, right? That is my model. Sorry, it's on several lines. So why is it 2D when it leaves? Because that was my T value, right? I need to just find T. Didn't they remove? I don't think so. Like, just make sure you revise everything, even if they say like those may just be rumors. All right, you want to be over prepared rather than under prepared. That's better advice. All right. So if this water wheel is spinning and the height of P is 3 plus something, where this is the cos function that varies, how am I going to change this so that the height of P is changed? Like, what is the bit of this equation that offsets the vertical height? It's the 3, right? That 3 tells me that it's going to be 3 above the ground level, right? So the only difference I need to say is, well, how am I going to adapt this model? Well, the 3 needs to vary, all right? So 3, if the water level is constant, so not at a constant, remember, because the water level is varying, right? So the way you would word this is here, the 3 needs to vary, okay? So that means it could increase or decrease, right? Because water is like waves, right? It goes up and down, up and down. So that's why. That's another like modeling questions. You got to use common sense. I hate using common sense in the exam, but that's how you do that, all right? So this is actually a nice question to get at the end of the paper. This, however, may put you off. My advice for your exams tomorrow, don't be put off by difficult questions, okay? Thank you, Bryn, for all the roses. I really appreciate it. So, uh, don't be put off. If you get faced with a hard question, could I repeat the answer? Yes. Give me 1 second. So, if you get faced with a hard question, close your eyes for 5 seconds. Take a 5 second breather. Breathe in. Look at this question with a fresh mindset. All right. So, uh, could I repeat the answer? The answer to which part? Part D, YR? And this is A level. This is not further. Um, and thank you, Talha. Everyone, make sure to follow. Yeah. Where I find this info for the one marker. All right. So the one marker. So it's telling me in reality the water level may not be of constant height. How can I adapt the equation of the model to be refined? Right. So what is my equation of the model? Is this thing here? H equals 3 plus 2 root 5. That cos thing, right? So how am I going to change this so that the height of P above the water goes up and down, right? I'm looking at this. The 3 is the only bit added to make it vertically change, right? Like as a set point, right? That's the only constant thing here. Because this 2 root 5 cos 0.5t plus that, this bit can vary, right? Because we know that a cos graph is sinusoidal, right? It goes up and down and up and down. So this bit already is telling me it's going up and down, but this 3 is just a constant. It's a constant offset. So it's 3, like I'm at 0, I'm going 3 up, so it's there, and it's going up and down about that 3, right? But that water level is not going to stay the same height. So that 3 needs to vary too, right? Because it could go up and a little bit down and up and further down like that. So this 3 would have to vary so that the water level goes up and down. How would you make cos? I hope that helps, YR. Does that explain it? To find max, would you make cos and sine equal to 1? Yeah, exactly. So for this question, cos would need to equal the cos of whatever's in cos needs to equal 1 to find the maximum. But if it was, okay, this is very important. If I put negative, subtract 2 root 5, the cos would need to equal negative 1, right? Because minus 2 root 5 times minus 1 makes it bigger. So be very careful if you have a negative. Will I do another live before apply? Yes, I am going to do, I'm planning on doing a couple of lives maybe next week. Stats and mechanics. I'm going to post the dates on my page once I've planned it all out. So I think I'm going to do probably 1 day stats, 1 day mechanics, and then the night before I'm going to do both. So I think that's how I'm going to do it, but I'll confirm on my page. So yeah, that was part of this paper, and we did the 2022 paper 2 before. I hope this was useful, guys. Thank you so much for following along, for all your support, and for following my page. Really appreciate all the help. Do you guys have any questions for the exam tomorrow or exam advice you want? Anything you want to ask before I end the live, or are we all good? Hey, Keanu. All right. So I'm gonna wrap up. Is there any mistakes people accidentally usually make? Yeah. So people common mistakes. Is it possible to learn mech in 3 days? All right. So I'm gonna answer these one at a time. So people's common mistakes, which I also had to be very careful of, and I've hammered them out throughout the live. Units. Notice I've noted the units on the side, right? Because in my final for my first paper, I forgot to convert from hours into minutes, and I lost like I think 1 or 2 marks for that. That I could have gotten that question correct, right? So be careful of units. Make sure you know the units of the questions. Degrees and radians is a common thing, and make sure you understand each question before doing it. The way I do that is I rewrite. If there's an equation in the question, notice up here, I rewrite that equation. I rewrote 2 cos theta minus sine theta equals that, just so I know what the question is, and I'll double check what I wrote to that it matches. So I 100% know I've read the question correctly. Okay. Make sure you underline. Notice I've underlined throughout and annotated all over this, so I can easily and quickly refer to key parts. Another common mistake people make are with negative signs. Obviously, with multiplying and subtracting and adding, be very, very careful with negatives. What other common mistakes are there? I'm just trying to think. With integration, make sure you know the how to integrate in the different methods. Okay, go through the chapter. Make sure you know. Um, the different methods of integration and differentiation. Make sure you know when to use the chain rule, product rule. Another thing, don't forget to use product rule. Sometimes when if you're doing a really long implicit differentiation, make sure you do the product rule on some of them. I think, is there a question up here on that? Let me just check real quick, where you had to use product rule on implicit differentiation. Here, see the QY, the QXY up here, I noted use product rule. So I remembered to do product rule there. Like, that's a thing people also tend to forget. Next question. Is it possible? It is possible if you don't have anything else to do to learn mech in 3 days, Keanu. What I did was, I'll be completely honest, before my finals, I had exam on Tuesday, nothing on Wednesday, and then last exam was stats and mechanics. I literally like just sat day and night relearning all of year one stats and mechanics fresh because I didn't revise that fully before like before the exam started. But year two mechanics, make sure unit 7 is the bigger unit. Make sure you know all the different possible things with frictions, hinges, tension, and all that. So yeah, it is possible, but I wouldn't recommend it if unless you are like mentally able to do that. Just gonna pray for 80. Yeah, praying for you guys to get your best. Are there any recommended? Are there any read book guides or documents you would recommend? The one they have on the what's it? The textbooks, right? The EdXL textbooks with those different color covers. Those are really useful. With use PMT to look at the work solutions and just going through that way. I'm not gonna lie, use ChatGPT sometimes and like drill it. Ask it for explanations or reasons, have a conversation with it to fully understand the maths. So I recommend using that. And PMT has a bunch of topic questions. Madass Maths, I also recommend. If you want some difficult questions there, use those. And just Google any tough questions you want. And Google if you struggle with a concept or why things are what, right? Like even nuances that I would be Googling like I'm not gonna lie. During my A levels, I was like, "What the hell is Pythagoras again? Like, why does Pythagoras work?" So I just had to go Google why does Pythagoras work and just teach that to myself again. Because doing a ton of maths all at once does something to your brain. So yeah, just the internet is there. Like, use everything you have. Use all your textbooks. Use your teachers. Okay, speak to the teachers before the exam. Go to them. All right, they're there to help you. Okay, it's better you just ask them there and then rather than just being shy or about it and not asking them, all right? Go to your teachers, all right? And feel free to DM me if you guys have any questions as well. I'll be happy to respond. What is the integral of sine to the power of 3x cos x? Let's see if I can do that now. All right, so integrating sine cubed x cos x. All right. All right. So notice that if I have, so I'm going to use the reverse chain rule. Why am I going to use reverse chain rule? Because cos x is a derivative of sine x, right? So I'm going to let y equal sine to the 4x. So increase the power of this x by 1. So dy by dx is going to be equal to multiply by the power 4 sine cubed x. Now chain rule, remember, sine x differentiates to cos x. So I have this, but I want this. So I'm going to multiply that by a quarter to get rid of the 4, right? So I'm going to multiply this by a quarter. So this is how you would integrate sine cubed x cos x. I hope that answered that question there, question mark. And yeah, that's how you get rid of the cubed. So you can only do reverse chain rule if you've got a function and is being multiplied or divided by something that looks like a scaled version of its derivative. So the derivative of sine x is cos x. Yeah, reverse chain rule, exactly. Which paper? This was October 2021, paper 2. I have Chem, oh, low power. That's crazy. I have Chem the day after. It's a hell schedule. Oh no. Did they put Chem at the end again this year? That was the same thing last year. They had, I think, second last day was stats and mech, and the last day was chemistry. So they had, oh, best of luck with that break. Right direction. Paper 2 tomorrow. Yep. Ba-ba-ba. Just follow you. Thank you guys for all the follows. Yeah, you can also use substitution, u equals sine x. 4 exams. Best of luck, Keenan. 4 exams. That's long. Just push through, all right? You're almost done, and then you're gonna have one of the best and longest summers of your lives. Trust me. Like my summer after my A levels, I felt so empty. I'm not gonna lie. I just felt so useless. I was like, what do I do now? But like when you're done, clean out all those papers that are all over your room. I know that you guys have a ton of papers everywhere, or the dining table's completely covered, all right? Clean it all up, close all your tabs, you're done, all right? Just make sure you save anything if it's like important and you might need it at uni. But yeah, like be free. So just push for this last couple of 1 or 2 weeks, depending on how many exams you have left. Then you can just get rid of it all and, sleep. I'm not gonna lie, I thought I'd be going out to celebrate, but yeah, I just slept. Alright, I'm gonna go now. Thank you, King of Frauds, for being on this live, and best of luck for your exam. No worries. And thank you, Ed, for the follow. No worries, question mark. This was the 2021 paper 2. So I hope this live was useful. And yeah, I'm gonna wrap it up there. Best of luck for your exams tomorrow. Let me know how it is. I want to hear how it was. So DM me or yeah. So yeah, hopefully that was helpful. Okay, I'm gonna stop waffling. Bye bye, guys. Take care.